improvements and so many solutions that have been deployed on Microsoft Azure. Whether it would be for indie developers, whether it would be for gaming platforms, for mobile, for enterprise solutions, Microsoft Azure has always been on the forefront of the cloud computing world. A quick Google search for an Azure architect can yield over 8,000 jobs alone in the United States itself. Microsoft has been introducing so many certifications for the cloud experts who are working with Azure. And not just for the sake of a job or for a professional certificate. So many engineers are always trying to explore more and more about Microsoft Azure on the basis of their personal interest. I am Afzal Ahmad Zishan, and I will be your instructor throughout this course. I am an author with Pact, and I have made several courses with Pact focusing on Microsoft Azure for caching, for storage, and for security purposes. I have been awarded as an MVP by C# Corner, by Code Project, by Alibaba Cloud, and Microsoft. You can always find me on Twitter, Facebook, or LinkedIn. Throughout this course, we will be discussing several options that Microsoft Azure provides us with in its platform as a service category so that you can deploy your own solutions without having to manage any of the infrastructure overheads such as the virtual machines, the operating systems, the virtual networks, the tunneling for the VPNs, or whatever. The platform as a service offering of Azure enables developers to quickly deploy their solutions to the cloud so that customers can access the solutions instantly. We are going to have 7 sections in this course. We will start with the discussion of cloud nativity. We will explore what it means for an application to be a cloud native application. We will discuss what several options does Microsoft Azure provide us to develop and to deploy cloud native applications for the public to consume our services. Then we will move ahead, and in the next section, we will discuss how the data can be stored on the cloud. We will discuss Azure Storage as the primary storage service on the cloud. We will also explore different options that Microsoft Azure provides us with, such as the Azure Storage Tables, the Azure Storage Blob, or the capability of deploying a static website on Azure Storage. Then, in the next section, we will go ahead and discuss how we can utilize the serverless platforms to enable more engagement with our customers. We will take a look at how we can create serverless websites and serverless forms that can take input from our customers and have Azure function store all that information into storage tables. We will also take a look at how we can connect different services such as Q&A Maker so that our customers can quickly just ask a question instead of having to go through a plethora of frequently asked questions or to have to scroll down a complete web page in order to just capture a single response. We will move ahead and discuss a little bit of security on Microsoft Azure. We will take a look at how Microsoft Azure and the Azure AD provide us the basic security principles and policies that we require to authenticate and authorize the users in our applications. We will go ahead and discuss how Microsoft Azure can be used to quickly enable authentication on top of our applications, or how different resources can communicate with each other and how different resources can share their information with one another. We will also go ahead and take a look at how B2B communication can be done and how Microsoft Azure and Azure AD can help us throughout this process. In the next section, section 5, we will discuss the automation and DevOps. We will take a look at the platform as a service-based automation. We will also discuss how Microsoft Azure supports the DevOps principles of infrastructure as code and which of the services does Microsoft Azure provide us to enable these features for our own applications. Then we will move ahead toward the networking section and we will take a look at how we can manage the traffic load for our applications, how we can develop the profiles that can enable our applications to support load balancing capabilities without having to utilize or use any internal load balancers. We will also take a look at how, if possible, we can utilize high availability features inside the platform as a service. Then, lastly, we will go ahead and take a look at how we can monitor our solutions. We will take a look at the application insights as a service that enables our applications to be monitored, to be logged, and to be profiled. We will also discuss a few other options such as how we can create some dashboards using Power BI. although that is not a must to complete this course. The prerequisites for this course are that you must have a basic understanding of cloud computing. It can be any cloud, whether it would be AWS, Google Cloud, or Microsoft Azure itself. You are also required to have an Azure subscription so that you can go ahead and follow along all the labs that I will be providing you with. And it would be really very helpful for you if you have already had a hands-on experience with developing and deploying a service on Azure, whether it would be a basic Hello Azure application. Do not worry, we will try to make sure that we are on the same page. So now let's get started with the first section of this course. Welcome to the first section of this course, Going Cloud Native. In this section, we will cover the basic concepts of the cloud computing. We will have your environment set up for the development as well as for deployment purposes. We will also take a look at different deployment models that are supported by Microsoft Azure and how you can deploy your services in different models such as platform as a service or software as a service. We will also take a look at why containerization is important and how you can do that. Let us first go ahead and take a look at the service model and see how it helps organizations to develop and distribute their packages to the customers. The basic terminology is an acronym which is used to explain that a service is basically an offering on the cloud platform, or it is leased or rented by the consumers and runs on a subscription model, which means that basically the product that you are providing to the customer is a service and they do not own the product itself. There are various names for this service model such as DBaaS, which is database as a service, SaaS, which is software as a service, PaaS, IaaS, and PaaS. And there are several other terms that are being used in the modern day cloud computing. The overall difference in these terminologies can be understood well when we discuss it from an infrastructure standpoint. For example, if you are a startup, your requirements for the hardware or the infrastructures are really very low because you merely have a couple thousand users per month. However, as soon as your user base grows, so does the need for your hardware. And soon enough, your budget will have to run out. So for example, if you had deployed your application in the PaaS model, you might want to move ahead to an IaaS model so that you can have more control over the hardware and you can utilize more applications and services using the same cost that you were paying for the PaaS model. When we are running our services on the cloud, we need to understand one thing, that everything itself is a service. Whether it would be any pre-built solution such as in a SaaS, or it would be any networking solution that you have deployed on the cloud such as a hybrid cloud solution, or your virtual machines that are running on the cloud, your runtimes or frameworks. Everything is charged for, especially the storage, where you have to store your applications, the user data, the databases, your machine learning models, everything, including the security that the cloud vendor is providing you with. Most of the cloud vendors, especially Azure, will sometimes try to provide an inbuilt solution for security, but most of the times it will go ahead and ask you to purchase a premium licensing for most of the security concerns. And later in this course, we will also discuss how authentication works and how Microsoft Azure provides us with the capabilities to integrate the security in our own applications. More than 95% of the Fortune 500 companies are currently running on Microsoft Azure. You can explore more options and more documentations on azure.microsoft.com, where you can read more success stories of various customers that have been using Microsoft Azure for their infrastructure and platform deployments. In simple words, the model layering that we are going to be discussing in this course are the IaaS models that provide you with the full control. And on top of the IaaS is built the PaaS model, which is platform as a service. Platform as a service basically provides you with the runtime control, and you have the control over the runtime versioning, and you develop your applications or solutions on top of the runtime. The topmost service model is the software as a service model, in which you are provided with a pre-built software and you only have the access to input the data and get the results out of. Now, since we are only going to be talking about the IaaS and PaaS, Let's go ahead and in the next video discuss the differences between IaaS and PaaS service models. So before we dive into the platform as a service model, let's take a look at what is the infrastructure as a service model and why we are only trying to discuss the platform as a service model in this course. IaaS model basically covers everything that your application or solution might require from a hosting platform. For example, it supports virtual machines, it supports networking, and it supports custom security policies that you can enforce on the applications. The IaaS model also requires that your engineers, whether they would be application development engineers or network engineers, they all should have a common understanding of what a cloud application basically means, especially the cloud native applications that have to be developed and deployed on the cloud. The main key point to take away from this video is that platform as a service is based on top of infrastructure as a service. Platform as a service abstracts away all the necessary information that one has to know in order to better develop the solutions for the infrastructure as a service and provides only the options that one requires to develop and deploy a cloud native application on any cloud vendor, such as a simple runtime to run the application and a basic compute platform to execute the application once deployed. Which means that in most cases the platform as a service offering is efficient. The efficiency comes from the capability of PaaS when it manages everything that falls in the IaaS category. For example, it automatically manages the hosting storage requirements and automatically configures the networking environments for us. So we do not require to manage any virtual networks. We do not need to create any port filtering. We are also provided with a basic firewall pre-configured for us. And most of the security policies are already enforced on the application, such as IP address filtering or port filtering. Most of the upgradation of the software or the patches that have to be applied to a runtime environment are all managed by the vendors, and you are not charged for any downtime that happens. Vendors must be responsible for the overall upgradation of the services and to provide you with an up-to-date environment. However, you are still responsible for all the code that you write for that platform. And this means that whatever you have to do in the infrastructure as a service category, you can easily do that in platform as a service category as well. So using this, we can say that platform as a service is cost efficient. Some might argue that there are other differences as well, but let's now move ahead and discuss the cloud native applications. Now that we have removed the infrastructure as a service from the list of concepts that we are going to cover in this course, let us go ahead and discuss how we can build cloud native applications for the platform as a service. First, let's take a look at what Microsoft Azure has to offer for platform as a service consumers, and then we will move ahead and discuss which open source platforms can we explore for the platform as a service offering to build cloud native applications on top of. Microsoft Azure has a couple of offerings for the cloud native application development and deployment. The Azure App Service is the most important one of these. And on top of Azure App Service, there are other offerings such as the web app for containers that one can use to deploy their applications in the containerized package form. Then, to complement the PaaS offering of App Service, Azure also supports databases as a platform as a service offering. The Azure SQL database is the most important as the most widely used service on Azure, and the Azure Cosmos DB also is a part of the PaaS offering by Microsoft Azure. When we discuss the networking side of the Azure, we can see that Azure Traffic Manager can be thought of as the load balancer in the platform as a service category. It can be used to maintain the high availability of the applications, and then we also have other services such as the Azure Application Gateway. The benefit of utilizing the PaaS components is that they are easy to manage and to ship to the public, as there is no requirement to configure anything for the infrastructure or the hardware. And all of the PaaS components basically follow the dependency models. Each of your application will have a dependency
on another service, and so on. And this ability of these components of being a dependency and being dependent on other solutions is what makes this service model a plug-and-play solution. And this enables us to easily remove one service and add another service instead of it. So for example, we can easily remove the Azure SQL database and replace it with Azure Cosmos DB. And most of the infrastructure management will be done by the vendor, which in our case will be Azure. The management of the platform as a service components can be done via coding interface or via graphical interface inside the Azure portal. And we have different services to build our solutions on top of. There can be solutions for monitoring, for caching, for databases, for load balancers, and for traffic and DNS managers. And we will explore all of these components in the coming sections as we proceed through the course.
So, before we get into the environment setup for our course, let's get a quick overview of what a cloud-native platform or a cloud-native architecture means. Cloud-native platform basically is a platform that supports cloud-native development of the applications. Cloud-native development means develop the applications that can utilize the full potential of the cloud, such as developing our applications following the microservices architecture or the service-oriented architectures. The connectivity between the applications is via the connectors or the services that are deployed as a PaaS-based service. Just like we discussed in the previous slides, how Azure App Service can be connected to Azure SQL Database or Azure Cosmos DB. Most of the development tools are integrated with the runtime, so the native support for development is provided with Visual Studio Code, the IDE which we will be using in the later sections, and the Node.js runtime is also supported on our local development environments as well as on the Microsoft Azure. And we will see how Azure automatically detects the version of Node.js required as well as the NPM. Now that we have introduced the cloud-native application, let us go ahead and set up our environment with the software packages that are required to follow along with this course. In this video, we will go ahead and set up our environment with a couple of install options such as Visual Studio Code, which will be used for the development purposes. We will also go ahead and set up and install the Node.js, which will be used in the next videos as the runtime of choice for our cloud-native solutions. And these are the two services which are necessary for you to follow along with this tutorial. Next three services are not necessary. MongoDB Compass, which can be used to explore the MongoDB collections or the MongoDB database instance state. You can also go ahead and install the Azure Storage Explorer, which will help you in understanding how many collections you have and what data is stored in each of the collections. In the last section, we will be utilizing the Power BI desktop to generate the reports for the metrics that have been captured by the application insights for our application. So if you want to follow along with that tutorial as well, you are more than welcome to download the free edition of Power BI desktop on your system. First, let's go ahead and install the Visual Studio Code on our machine. You can download Visual Studio Code from code.visualstudio.com. On the first page, you will be provided with a download button. If you will be using Windows, it will provide you with a stable build. If you are using other operating systems, it will provide you with a suitable executable file for that platform. You can also go ahead and under the drop down find out the stable or the insider builds if you want to try out the latest but experimental features. Once done, the second option is the installation of Node.js. You will find that on nodejs.org. For most developers, it is recommended that you utilize the LTS edition because it supports most features and is also stable for production purposes. Next, visit the mongodb.com website, and under the download center, you can go ahead and find the MongoDB services. Under the tools, you will find MongoDB Compass. MongoDB Compass is basically a graphical program which allows you to study the database structure and to perform a couple of options on that. You can go ahead, select your platform and install the service. Next, we will go ahead and install the Azure Storage Explorer. You can find that by using a quick Google search for the Azure Storage Explorer. On the Microsoft Azure website, you will be provided with a drop-down to select the platform which you are currently running. Once done, you can go ahead and download the executable for Azure Storage Explorer. Once that is set up, we will go ahead and lastly download the Power BI desktop. You need to create a new account. You can sign up for a free account, and once done, you can download the Power BI either from here, or if you are running Windows 10, you can also go ahead and visit Microsoft Store to download the Power BI desktop app from the Windows Store. These are the couple of packages that you need to follow along with the course. Now, let's go ahead and take a look at how we can build a cloud-native application for platform as a service. For every software engineer, the development aspect of the cloud engineering is the most interesting part. The cloud-native applications require you to select the framework which is cloud-native in nature itself without having to develop a monolith application and then distribute the applications in different regions. That doesn't work quite well on the cloud. So for example, your end-tier solutions might not be able to utilize the cloud as good as the microservices architecture. So that is why I personally recommend that you utilize the Node.js runtime as your development runtime for the cloud solutions. Node.js is a very lightweight but super fast runtime because it utilizes the Google's V8 powered JavaScript runtime for web servers. It is event-driven and stateless. Node.js is platform as well as architecture agnostic, so it can support any cloud, any virtual machine, and any deployment model that you can utilize or support. Node.js also supports the industry standards such as the asynchronous pattern of development. And due to the fact that it has an event-driven architecture and it is really very lightweight, one can quickly and easily develop their microservice solutions on top of, and then they can go ahead and deploy those services as microservice, or they can package those services in Docker containerized fashion and then deploy those services on top of app service or other services. Node.js basically also supports cloud native development, and you can explore more about how you can do cloud native Node.js development on cloudnativejs.io. Let's head over to Visual Studio Code and explore the application that I have written for this demonstration. It's a hello world application that does nothing but just have a simple application and shows a couple of information about the application and the process. Inside the app.js, I basically have created a new server. I have went ahead and configured a couple of routers that provide the views. Inside the routers, we have home.js, which is the default router that provides the home functionality for the default page, the about, the contact. I also have created a demo API that will provide the responses in JSON. Let's go ahead and start this application. For that, let's head back to the terminal and run npm update. npm update will make sure that our packages are up to date, and then execute npm start. It will go ahead and start our application. As you can see, it says server listening on localhost 5000. You can simply ignore the error message that is being shown. It is basically there because I have not provided the application insights instrumentation key for this application in the environment variables, and it is not necessary because I do not want to monitor the application while it is being developed over here. We will go ahead and take a look at the monitoring and tracking of the application usage in the last section of this course, and we will explore how we can connect the application insights and the app service right from the portal itself. Now, let's go ahead and set a new request to localhost 5000 and wait for our process to return. And as you can see, the application works quite fine. And this shows that our application is ready to be deployed on the cloud. In the next video, take a look at the basic differences between the deployment as a web application and the deployment as a Docker container on the cloud platform. Since Microsoft Azure's web applications also provide the offer in which you can utilize the container deployment, it is quite a difficult challenge for you to decide whether you want to deploy your application as a code or as a containerized package. Azure PaaS basically utilizes the app service environment, which are the virtual machines that are deployed, and they can run your multiple applications on top of. App service supports both virtual machine types, Windows, as well as the Linux virtual machines, so that if your application requires a Windows operating system, you can utilize that, or if it demands a Linux environment, you can provide the virtual machines for Linux too. When choosing between the pricing tier or the service model
for the application service, always go for isolation instead of shared environment. You should also consider the amount of scalability or the type of scalability that the platform provides, such as automatic or the custom scalability. Also, the high availability that the platform provides you with. Let's first go ahead and talk a bit about the containerization and the containerized packages that can be deployed. Containers basically can be used with orchestrators such as the Kubernetes, Docker Swarm, Azure Service Fabric, or DCOS. Azure also supports the Service Fabric, which is a Microsoft's product for orchestration of the services. Containers can be deployed using configuration files such as Docker Compose or Kubernetes services. The deployment of containerized packages also requires that you either grant access to the private repositories or you create your repository for Docker images and packages on Azure. We will, however, try to focus on the web applications instead of the orchestrators which utilize the infrastructure itself, such as the Kubernetes or DCOS. The benefit, however, of containerized package deployment is that the deployment happens within a couple of seconds. Once the container has been downloaded by the platform, it only takes a command for the container to boot up and serve the requests. Let's head over to the Azure portal and take a look at a couple of options in which we can deploy the services. First, head over to the resource groups and create a new resource group. It is always a good practice to create a new resource group for every service that you want to try out. Select the subscription, enter the name of the resource group. In this course, we will follow a convention of the section, then the number of section, and followed by RG, which stands for resource group. You can select the region, review the service, and create the resource group. We will then go ahead and create the new resources within this resource group so that at the end of the section, we can go ahead and delete the resources when we no longer need them. It will protect us from incurring charges on the resources that we no longer need. Let's head over and create a new resource inside this resource group. Head back to the home page, create a new resource, and visit the web category. Under the web category, you will find web app as well as web app for containers. These two are different offerings. However, let's head over to the web app. As you can see, the web app basically provides you with the basic form that you can use to configure the subscription, the resource group. Remember that we created a new resource group. We will be selecting that resource group to deploy the service in, the operating system, Windows or Linux, and how you want to publish the package. It also enables you to control the runtime stack. We will go ahead and select the Node.js 10.1. It doesn't really matter on the Windows platform because you can go ahead and configure it later on as well. Let's input the name of our service, which can be anything. You can also select the publishing model, which can be either code, using which you will have to deploy your code, or you can select the Docker image, using which you can provide the name of the image that you want to deploy. There are different properties such as single container, Docker Compose, or Kubernetes. The Docker Compose or Kubernetes is only supported on the Linux operating system based applications. So we can go back and configure the operating system to be Linux, head back to the Docker image, configure the container, and if we head over to the Docker Compose, you can see that we can configure the Docker Compose based on the Azure Container Registry, Docker Hub, or we can also configure a private registry that we have. You will have to fill in the information for the Docker Compose, and once done, you are good to go. Let's give the name to this application, Express App Code, and once done, you can go ahead and create the service. We will switch this back to the code because we would like to deploy our code inside this application. And while the deployment is in progress, let's head over and create a new resource inside the same group. This time we will choose Web App for Containers. The difference between Web App and Web App for Containers is that Web App for Containers only provides the support for containerized packages. Head over, select the subscription, the resource group that you want to deploy the service in, the operating system for the containerized package. Just remember that this operating system will be the default operating system of your Docker engine. Provide a name for this service. Let's call it Express App Docker. Head over and configure the operating system. Since we will be using the Node.js service, it is fine to use either Windows or Linux operating systems. Head over and click on the Configure Container. We can use single container, Docker Compose, or Kubernetes, just like we talked about for the previous resource. Let's head over and utilize the Docker Hub for hosting of the images. I will copy the name of the image that I have deployed on Docker as well as the label for my image. I will just input the image and the tag over here and apply. You will see that Azure has filled in the details for my service, and once I'm done with this, I can just go ahead and click create. Now Azure will go ahead and create a new deployment for web app for containers. On the previous page, we can see that the deployment was successful and the application was created. Now we will let the deployments take place, and in the next video we will test the applications and see if there is any difference in both the applications, and we will also explore what are we going to cover in this course. Let us quickly go ahead and test the deployments that we have made in the last video. Let us head over to the portal and visit the website that we have deployed, which was using the code base for the application deployment. So this is the default page that Microsoft Azure deploys for your websites. As you can see, it greets you as a Node developer because we have configured the runtime to be Node-based application. Now, on the second tab, we can see that the other deployment is also made. Let us quickly go ahead and review the container settings and study the logs that have been produced by our container. We selected the single container instance, and the same has been configured under the container settings. What we are interested in right now is the logs that are produced by the container. Let us go ahead and quickly refresh to see what are the logs. And as you can see, these are the logs that are produced by the container, also by the Docker engine while running the image as a container. Basically, it shows that it was downloading the image from the Docker Hub, and then it ran the image using Docker run command, and it passed in all the variables that we have configured in the application settings to be used for this application. And as you can see in the last line, it says that the container is initialized successfully and now is ready to serve the request. So let us head back to the overview tab and browse the website. So if we send over the request to this page, you will see that it responds now and transmits the same HTML page that we saw in the local deployment. Since our system is Linux based, you will see that most of these configurations are disabled, such as application insights, the web jobs, MySQL in app, etc. Get back to Visual Studio Code. Let us open up the terminal, review the Git status for our application. As you can see, there is nothing that needs to be commit, and we are working on a clean branch. To make the deployment via code, let us head over to the Deployment Center under Deployment. On this blade, you will select the source control that you want to use. There are a couple of options such as Azure Repos, Local Git, Bitbucket, and GitHub. We will select Local Git and then simply continue with this. You can choose the option that is best suited for you. Let's continue, and on the second tab, you have to select the build provider. The build provider acts as the environment where your code has to be compiled, built, and packaged in an executable format. You can utilize Azure pipelines, but we will not go into the deeper depth of the Azure DevOps in this course. So let us stick to the App Service Plan's Kudo build server. We will select that, and once that is done, Deployment Center will provide you with an overall summary of what you have just selected. It will show you the repository, the branch, and the build provider that you are using to compile and package your applications. Once the setting of the deployment is configured, you will be provided with the URL for the Git repository that you can use, and a couple of more options such as how you are building, what is the source for it. You can go ahead, disconnect this source if you want to change the source to any other provider such as GitHub or Bitbucket. What we need to do is visit the Deployment Credentials tab. At this time, what we need to do is we need to add a new remote repository inside the Git. We will go ahead, name it Azure App Service, and provide the URL that we just copied. So once that is done, just clear the screen so that we have extra space to review how Azure accepts the changes. Now, we will just go ahead and push all these changes to the Azure App Service into the master branch. Once you will press enter, it will ask for the credentials for this repository. Since this is a new repository for the Git, we will now head back to the portal and copy the username as well as the password that is available inside the portal for you. Once you provide these credentials, Git will go ahead and push all these changes over to the Azure App Service. Azure will go ahead and show you all the changes that you have made, and it will show you the overall status of the deployment. And once everything is done, it will show you that it has finished successfully and it has run the deployment of the application as well. If there are any errors, it will show you right over here so that you can make the changes and then you can redeploy the application. Let's head back to the application and send a request to the application once again. And this time, as you can see, application responds with the responses that we have written in our own Node.js application. So that is how you would deploy the code. It definitely depends upon your use case, your business model, and how your applications are being developed and deployed on the cloud. So now this brings us to the end of this section. In this section, we discussed the definitions of the most commonly used idioms as well as abbreviations on the cloud. We discussed the cloud nativity and what it means for an application to be cloud native in nature. We studied the differences between virtual machines and the containerized deployments. Just remember that the code-based deployment that we have just made is done on a virtual machine that is managed and provisioned by Microsoft. So the containerized application has to be developed using the Dockerized packages. Then we also studied the differences between the deployment models. We also went ahead and saw which of the packages do we need to install for this course. So this was just the first section of this course, and we took a look at what are the basic concepts that you need to know in order to follow along with this course, and we tried our best to explain the concepts that are needed for you just in case if you don't know them. Now, moving ahead, we will take a look at the databases and data sources that can be deployed on the cloud and follow along how they can be distributed across the globe. We will also take a look at how we can store the user as well as app generated data on the cloud. From there, we will go ahead and study the modern approaches of application development as well as deployment, such as serverless or machine learning based solutions that have to be deployed on the cloud. We will also study what best practices you can employ for the security as well as for monitoring and tracing of your applications on the cloud. But now, in the next section, let us go ahead and study how we can store our application data or user data on the cloud. Now, in the second section, let's go ahead and take a look at how we can store our data on the cloud. In this section, we will try to explore different database options that Microsoft Azure has provided us with. We will also try to take a look at how many caching solutions can we utilize on the platform as a service offering. We will also explore how we can store the user-generated data from our web applications, and we will also take a look at how we can store the resources for our web applications to function properly. In the first video, let's go ahead and try to understand the concept of database as a service. In the previous section, we understood the concept of what it means to be an as a service model, where we discussed the DBaaS offering and we tried to explore how we are only responsible for the data that we are storing. This means that the DBaaS solutions only have to take care of the data definition, for example, the schema definition for your databases as well as the tables, whereas rest of the stuff, especially the infrastructure management or the security protocols, are all managed by the cloud. Most organizations deploy their solutions on top of the cloud. The benefit of utilizing the cloud as a solution hosting partner is that you can utilize all the offerings such as the scalability and the high availability of the cloud. You can quickly deploy your solutions in a separate region on the globe without having to provision extra infrastructure or operational teams. Since your applications are already cloud native in nature, your databases should also try to focus more on being cloud native in nature. You should also develop your databases focusing the cloud nativity for performance and scalability. It is a common myth that people believe that when your data is uploaded to a cloud, the cloud vendor owns the data. In post-GDPR world, that is not the case anymore. You are still the owner of your data and you can always claim deletion of your data as well. So at the end of the day, the cloud vendors are only responsible for managing the hardware and the software upgrades that are necessary for your databases to run properly. When talking about Microsoft Azure, there are several database offerings provided by Microsoft or the open source or third-party vendors on the open cloud market. For example, MongoDB or SQL Server are provided as the relational and NoSQL databases. There are several storage mediums available such as the Azure Storage. There are high throughput services available as well, such as the caching solutions, most notably the Azure Redis cache instances that are available on the cloud as a PaaS offering. Microsoft Azure has so many database approaches that you can consider from. For example, it has relational databases, the ones we just talked about. It has NoSQL databases, and the most important one of which is the Azure Cosmos DB. It has offerings for graph APIs such as the Gremlin, and it also supports key value data storage such as in the Azure Storage Tables. We will be taking a look at a couple of these, if not all of these, in this course. And the benefit of utilizing the Azure platform for this is that it supports linear scalability for all the database offerings that it has. All of your databases are replicated globally and they can be easily distributed across the globe. It is quite easy to migrate from or to your on-premises using the hybrid solutions by Microsoft Azure. And Microsoft Azure also provides software packages for consumers who would like to migrate their on-premises databases to the cloud. Microsoft Azure is also committed to providing security and privacy for the user's data as well as for your application data. And at the end of the day, it is cost effective. And the overall goal of having your databases as a PaaS offering is that they should be capable of scaling as your application scales. So if your applications are running in a containerized package, so should your databases. And we will see later on in this section how we can quickly utilize the services offered by Microsoft Azure without having to manage anything ourselves. And now in the next video, let's go ahead and take a look at how we can do that by using Azure Cosmos DB to deploy a MongoDB instance on the cloud and study how easy it is to replicate and distribute the data across the globe. In this video, let's go ahead and create an instance of Azure Cosmos DB and deploy a MongoDB instance for Platform as a Service on Microsoft Azure. The benefit of using Azure Cosmos DB is that it is basically a multi-model, globally distributed, and high-throughput database. The meaning of multi-model is that it supports multiple models of databases. For example, it supports key value pairs, it supports relational databases, it supports NoSQL databases, and it supports fault-tolerant databases as well, such as Apache Cassandra. There are several offerings of NoSQL on Azure. Some templates for MongoDB are created as a virtual machine and are deployed on Microsoft Azure virtual machines. Some instances of Apache Cassandra are found. Microsoft itself had DocumentDB. Then there are other database instances such as key value pairs in Azure Redis Cache, then Azure Storage Tables, and so on. The sole reason why we are not considering any of these options is that virtual machines basically do not fall under the Platform as a Service offering, and they are outside the scope of this course. You are more than welcome to explore those offerings as well. However, we will try to utilize the Platform as a Service offerings in this video. To create a new instance, let's go to the Azure portal and create a new resource. You can search for MongoDB and there will be a couple of options available on the portal. As you can see, the MongoDB basically is a virtual machine instance which will be created under your subscription. Once you select the software plan and click on Create, a new instance will be deployed. Of course, some information will be asked from you and then the instance will be deployed on the cloud. Like always, we will go ahead, create a new resource group, and then proceed with the creation of the MongoDB instance. Instead of MongoDB, this time search for Cosmos DB. When you start typing Cosmos DB, Microsoft Azure will continue to provide you with some suggestions. You can open up the instance, review the information, and then click on Create. On this page, you will be asked a couple of information. You can select the subscription, the resource group that you have just created to follow along with this section. You can input the instance details such as the account name. You can select the API model, the location for this service. You can also try to enable the geo redundancy or not. You can also check if you want to support multi-region writes. These settings configure how the Cosmos DB instance is deployed on Microsoft Azure. We are only going to enable geo-redundancy because we would like to see how our application can be deployed in multiple regions. You can go ahead and configure the networks if you would like to deploy it behind a virtual network. We will go ahead and review the service and create it. Once you click on Create, Azure will go ahead and submit a deployment for your service. This deployment will take a couple of minutes before your service is ready. I will go ahead, pause the video, and come back once the deployment has been made. Now that our service has been deployed, we can go ahead and take a look at the service. The first time, Microsoft Azure will take you directly to the quick start of this service. Under the quick start, you can see that a couple of runtime options have been supported, and you can review the code sample provided over here. Use the connection string. For example, we are under the Node.js tab. We can explore a couple of options that are available over here. We can try out the code samples or read the documentation. Azure Cosmos DB also supports an online data explorer, which allows you to check out how many collections does your data have and what data do you have in each of the containers. You can also go ahead and create a new collection if you would want to. The pricing model and the throughput for each of these collections will be provided to you, and you can review these settings and create one if you would like to. Then there are some information such as the connection string for your Azure Cosmos DB. Basically, this will be the connection string that you are going to use to connect to your database engine, which in our case is a NoSQL MongoDB. Then some preview features are available, which you can review and study if you would like to. The replication of your data is also supported from within the portal. Azure Cosmos DB will update the information and provide you with the regions where your data has been deployed, and once it has done updating, it will also allow you to modify the regions where your data will be replicated. Now that it has loaded, we can go ahead and select a couple of locations such as South Korea, France Central, East US, and once done, we can go ahead and click on Save. Once we click on Save, Azure will redeploy our Cosmos DB instance on all of these locations as well. And that is how we can easily deploy an instance of MongoDB throughout the globe without having to provision any infrastructure or any virtual machine, which in the case of an infrastructure as a service model, we might have to configure the virtual machines and we might have to provision the high availability zones or the availability sets for the virtual machines, which in the case of platform as a service, we do not need to. We only require to purchase the subscription for the Azure Cosmos DB, and rest is managed by the Microsoft Azure. Now, since we have explored the NoSQL instance, we can also go ahead and do the same thing for a relational database. SQL Server is a service which is provided by Microsoft and hosted by Azure. The servers for SQL Server are also provisioned by the infrastructure, and we only have to pay for the instances that we use. Everything ranging from the security and firewalls is also implemented by Microsoft Azure, and I personally believe that SQL Server is a cheaper solution than Azure Cosmos DB. But this statement is highly debatable. And at the end of the day, a DBA is definitely needed. And this course does not talk about the database administration or how we can deploy the databases and design the databases. So you can definitely consult your DBA and ask them what is better for your business. Now, let's go ahead and take a look at how we can store the application data on Azure Storage and what benefits do we get when we store our application data on Microsoft Azure. Let's go ahead and talk about the application data storage on the Azure and what benefits basically we will get. As you might already know that everything is charged for on the cloud, whether it would be a user request, whether it would be application data to be stored, or the caching solutions that you might have. In my own opinion, I have personally explored that if you have separate services serving content, it can support your overall cloud charges. So, for example, if you have a web application instance such as the app service and that serves the user requests, you can have other services such as Azure Storage serve all the static content, which will be the CSS, the JavaScript files, or your images. This can quickly balance the load between the services. And since the Azure charges for the networking on different services in different regions separately, it means that you can have a limit of 5 gigabytes per region for your services, which can easily help you out in most rare cases where you might need to set up a load balancer to manage the user traffic. And since Azure Storage supports the caching and replication all built in, you don't necessarily need to deploy separate services. You can do that all from within the service itself. The Azure Storage Service supports 4 types of data storage. The primary ones, or the most widely used ones, are the blobs. Blobs are basically the binary large objects, and it can store anything such as your images, JavaScript files, your documents, user reports, or anything. The files are basically the SMB protocol based file sharing service that you can use to connect to files or other storage mediums using the SMB protocols. Then we have the queue storage, which can store the information in a queue data structure, first come, first serve. Then we have table storage service, which can store the data in the format of a key value pair and can be used to replace the most normal relational database requirement. Now, let's go ahead and try to create a new instance of Azure Storage. In the Azure portal, create a new resource, visit the storage category, and select the storage account. On this page, you will be provided with some basic information and you can review it. You can also go ahead and select the subscription, the resource group that you have created for this section, and then you can input the instance details such as the storage account name. You can also select the location, the performance type. You can also go ahead and select the account type. We recommend that you use the storage v2, which is the version 2 general purpose account type, and leave the rest as the default. Once everything is done, click on Next, Advanced. If you want to modify any of these settings, go ahead. We will just go ahead and review the service and create the new instance. Clicking the Create button, the instance deployment will start, and once the deployment will be done, you will be provided with the storage account under the resource group. You can review a couple of the options that are made available to you. You can also explore the options for the data storage that are available. You can go ahead and explore the settings, such as explore the access keys. You can also go ahead and study the replication model that your Azure storage is following. You can also go ahead and review the blobs that are stored, create new containers in the storage account, map the custom domains, apply the Azure CDN, or you can also go ahead and integrate the Azure search service, which will allow you to quickly search for the data that is stored in the blobs. Let's go back to the overview and explore all the services that are available. You can see that there are blob services, files services, the tables data, as well as the queues. You can go ahead and explore our course, Learn Azure Storage SDK, in which we dive deeper into the Azure storage itself, and we also explore the SDK that is made available for .NET as well as for other open source runtimes. Now, let's go ahead and try to look at how we can integrate Azure CDN with Azure Storage and how the caching and replication on Microsoft Azure works. Now let us quickly go ahead and try to create a new Azure CDN profile in the Azure Storage Service and take a look at what other options does Microsoft provide for the purposes of caching and replications. First, head over to the Storage Account service, scroll down until you find Azure CDN under the Blob service. Here you can find everything related to the Azure CDN, including the endpoints if you have configured already, and also another form where you can create a new endpoint and configure it to serve the request for this Azure Storage account. You can enter the details from a new profile or use an existing profile that has already been created but is not connected with this Azure Storage account. We will not go into the depth of Azure CDN in this course because it has already been covered in depth in the other course, Learn Azure Storage SDK, where we explored the usage of Azure CDN on top of Azure Storage Service. The purposes of caching are not only to just store the most accessed data, but it also helps us in maintaining and storing the user sessions as well as the states for the application. It is also used to store the application configurations in distributed environments so that your applications can access the most recent or the most latest configuration settings for the application, regardless of where they are deployed and how they are running. And the benefit of using these caching services on Microsoft Azure, such as the Azure Redis Cache, is that all of these services are highly scalable. They are also industry accepted and have a proven record of supporting enterprises achieve more. All the solutions on Microsoft Azure are globally distributed and are accessible by the customers, which of course you can secure by deploying them behind a virtual network. Another major feature of all the services is that you only pay for what you use and for the time that you use instead of having a commitment with Microsoft. And since most of these services utilize the open source services such as the Redis protocol, all these services have an official as well as community SDKs such as .NET SDKs for the Redis, which is developed by Stack Exchange and is supported by the community. The benefit of utilizing the distributed caching systems on the cloud, for example, you have multiple regions deployed on the cloud and your users are trying to access these services behind the load balancers. Now, load balancers will abstract away any downtime within a region on the cloud. But if your caching service is not sharded away and is deployed as a single instance, it will impact negatively on the services if it goes down. So what you can do is that, for example, for each of the region, you can have a separate instance of the cache bucket which is stored in the region itself. So if a region goes down, the cache for only that service goes down. However, it is not the most optimal solution. You can go ahead and deploy the caching service as a separate instance. So even if the region goes down, your cache is still stored. And that is what Redis itself as a protocol is good at. It can quickly replicate using the master-slave configurations so that even if a node in the cache goes down, a slave will automatically take its place and serve the requests. And for that, we have another course, Azure Redis Cache. We take a really very deep dive into the Redis protocol as well as how Microsoft Azure supports the Redis protocol and provides services such as geo-replication, fault tolerance, scalability, partitioned, or master-slave protocol. You can review that course in our library at Pact. Now, in the next video, let's take a very quick overview of what it is like to manage the state and session on the cloud. Users can access services such as Azure Active Directory to manage the state and session on the cloud. They can also control who can access the services, and they can quickly remove a session for a user whose account has been compromised. Azure Active Directory supports SDKs for native authentication, and we will explore all those options in the section 4 when we will be talking about the authentication services on Microsoft Azure. And if we do not want to integrate the Azure Active Directory, we can perform all these actions using a database service as well. For example, we can maintain the session information in the Azure SQL service that we just talked about in the previous video. We can also explore the integration of Azure Redis Cache instances with our applications, and we can maintain and manage all the session states in the Azure Redis Cache instance. We can also explore the usage of Azure Cosmos DB and its multi-model approach to the storage of session information. We can also go ahead and take a look at how Azure Storage Tables can be used to persist the session and state information. The difference in all these services is the library that we are going to be integrating. If you try to take the course of the Azure Redis Cache instance that we have provided, you will see how we managed to store some information about the users in the Azure Redis Cache instance and how we tried to explore the communications between multiple users using the publish-subscribe pattern, Azure Redis Cache, most notably the Redis protocol itself. The benefit of storing the session or the state management in a cloud service is that when you utilize an outproc session management, it becomes fault tolerant. The outproc basically means that the session or state information is stored outside the process itself. So if the process crashes, the data still lives. So if your process comes back, it can continue processing from where it left. Microsoft Azure provides really very cheap solutions for user session management. For example, the Azure Active Directory provides free user management, and you can store up to 500,000 users, and you can easily maintain access to their profiles and maintain their identities. Most of the Azure solutions are platform as a service offerings, which means that they support scalability and high availability for a better performance output. But this also means that your applications must also be cloud native in nature, and they must also follow the scalability and high availability requirements. Now this brings us to the end of this section. We try to explore how we can utilize the Azure storage as a cloud storage channel for our applications. Then we moved ahead and tried to discover how Azure Cosmos DB can be used to create instances of MongoDB, of SQL-based relational databases, Apache Cassandra, table stores, or document DBs. We also talked a little bit about the caching solutions and how we can replicate our data throughout the globe. In the next section, let's go ahead and discuss how serverless options can be utilized to engage our customers and provide them with an option to engage more with our application using machine learning models.
In this section, we will take a look at how we can engage our customers and how we can retain our customers so that they come back to us again. We will discuss a couple of new features such as the serverless development and deployment. We will take a very quick overview of Azure Functions. We will also study the cognitive services that are provided by Microsoft Azure and how we can notify our users or our own developers or the customer support managers. Classically, the solutions were developed keeping in mind that an application will be built and it will be deployed on a web server, and our customers would be sending a request over to it. They would be sending over some queries which will be stored in the databases, and so on and so forth. With the advent of serverless development of the solutions, more and more enterprises are looking forward to developing serverless client management services. If not the client management, at least the service should be able to respond to a couple of queries by the client. For example, you might already know of the chat ops concept. Serverless is no different. However, it is much more similar to the DevOps, only that there is no ops part in it. The serverless architecture is a bit different than the monolith application development pattern, because now not only just we build our services following the microservice architecture, but we also try to ignore the operational side of the development as much as we can, so that our teams only have to worry about the code that they write, not the way it executes and how it scales. So to recapture, applications only have to target the runtime, for example, C#'s .NET Framework, or JavaScript's Node.js, or Python or Java, and to make sure that the runtime that they are targeting supports the serverless framework on the cloud. Microsoft Azure supports a couple of languages and runtimes for its serverless development. Another major difference is that your applications are not developed or deployed as a single process. Instead, they are developed as modules or simple functions, if you may like to call them that. This means that your modules must execute real quickly, like within a couple of milliseconds. If your function requires a long-running task or it has to wait for other services to respond before it can process properly, then you might want to utilize some queue services and handle the bindings or triggers on top of them. And the Azure Functions, which is a serverless runtime by Microsoft Azure, it is basically deployed on top of Azure App Service and utilizes all the basic functionalities supported and provided by Microsoft Azure App Service, and provides a couple of more options on top of it. The basic design or the architectural design of this is that on top of the Azure App Service, you basically have a function application running, and within each application you have a couple of task runners, which are basically the tasks that your application has to perform, such as to notify a user, to capture a web request, or to process a file that has recently been uploaded to a cloud service. And not just the Azure Functions support the serverless architecture, there are other instances by Azure that support serverless development and deployment, such as the Azure Container Instances. It hosts your containers in a serverless fashion where you don't have to think about the scalability or high availability of the solutions. You only have to worry about the code that you write. And in this way, your applications don't even have to be serverless in nature. It can be a containerized package written as a microservice application. And the underlying service, which is the Azure Container Instance, it manages the scalability, the redeploying upon failure, and every other aspect of the solution. And most of the times, you can quickly just go ahead and connect it with the Azure storage tables for a really very cheap backend database. instead of having to provision and deploy a complete Azure Cosmos DB service, which is sometimes expensive. And on top of Microsoft Azure, there are several other options which support serverless-based solutions. Azure Function, which we have just talked about, is a service that supports programming the functions and then deploying them on the cloud. Then we have Azure Logic Apps, which provides a graphical interface to configure the bindings between the services and the triggers. Azure Container Instances, as we have just talked about, are for the containers. And there are so many other options supporting the serverless development of the solutions. However, now let's move ahead and in the next video, how we can utilize the Azure Storage Tables and Azure Functions to create a really very quick contact form for our users to send us some support queries. Let's go ahead and deploy a simple web page on top of Azure Storage Tables, and by using Azure Functions, let's give our users an opportunity to send us some support queries. In this video, we will only be taking a look at the front end of our web application. We will deploy a simple yet effective contact page for our application. We will be utilizing the Azure Storage Service for the deployment of this page, and you will see how we can develop serverless websites on top of Azure Storage Service. We will then go ahead and take a look at how we can connect the Microsoft Azure Functions to listen to the request, and Azure Function will be serving as the backend for this website of ours. Thus, it means that there is no requirement to manage the operational side of this web page. It will be managed by Microsoft Azure itself, whether from the Azure Storage side or from the Azure Function side. If your business is small and you only capture less than 1 million support queries every month, you can quickly use this option of deployment and perform this action in under less than $5, which is quite affordable instead of having to deploy a complete website and then manage a database at the backend. To deploy this solution, let's go to the Azure portal and create a new resource in our resource group. We will first go ahead and create a new storage account. Under the storage category, go to the storage account, select the subscription and the resource group for this section, input the details for the instance that you want to create. You can use any details. Just make sure that the replication model is set to geo-redundant storage, which has read access on the secondary region as well. Once done, go ahead, review and just create the service. Once you are done with that, move ahead and create a new function application. The process for that is quite similar. You just search for a new function application, input all the details, select all the services, and once you are done with the selection and input of all the information, go ahead and create the new service. Azure will deploy your services, and once done, open up the function application and head over to the functions. Inside the functions tab, create a new function. Depending upon how and where you are in the function, it will show you some different options to create a new function. Just make sure that you are using the HTTP trigger to handle the input and then go ahead. As you can see, this is basically the default content inside the function. I will be bringing in my own code which I had written, and inside this code, basically what I am doing is that I am capturing the request which is being sent over to this function. Since we already know that we will be sending the code through a form, we know that we can capture a couple of fields such as the name, the email, the message. And once that is done, I'm storing all that content inside the table, which is on the Azure Storage Table. We also need to modify the function.json file to support all the properties which we need. For example, we need to connect to an Azure Storage service. Once done, just go ahead and save the service. Now move ahead to the integration tab. Under the outputs, click new output. From the available fields, select Azure Table Storage. But before we actually configure any of these things, let's go ahead and install the extension. You do not need to perform anything. If you haven't, just click this install button. Once you are done with the installation of the extension, you can go ahead, modify all the properties which are available, review the information such as the storage account connection which is available. Once you are happy with all the features and values, just click save. Make sure that your integrate tab as well as the function properties or the function script have the same values. For example, the table parameter name. They must be similar. Once done, just go back to the function, save it as necessary, and you're done. Inside the Visual Studio Code, I have both the files open, the serverless contact form as well as the loss.html. These two files are required by Azure Storage Table at the least, and within this file, basically what I'm doing is I have a bootstrap based HTML page configured. It has a simple form which basically have some fields and it will take the input from the user.
The only change that I'm going to be making is that I'm going to be editing the action field for this form. The value for that will be taken from the function application itself. Let's head back to the portal and click on the get function URL. It will provide you with the function URL as well as the key which will be used to authenticate the request. Let's go ahead, paste it inside the function, save the file, and we're good to go with that as well. Now, what we need to do is, let's head back to the storage account that we have just created, and let's head over to the static website service available under the storage account. As you can see, it has been disabled. Let's go ahead, enable the service, input the names of the files, serverless contact form, as well as the lost.html. Once done, let's save the service, and as you can see, Microsoft will be providing you with the primary endpoint as well as the secondary endpoint. Once done, head over to the blobs under the blob service, click on the web container which is created for this website, and now you can upload the files over to this service. I will select both of the files over here and upload them. Once done, we can just go ahead and copy the primary endpoint, visit the endpoint itself, and have our web page served to us. And as you can see, this page basically comes directly from the Azure Storage Service. Now, let's just go ahead, input some details inside the form and submit the form. Before the submission of the form, we need to make sure that a table with that name is available under the storage service. So let's go ahead, open up the Storage Explorer. You can see that I'm using the in-portal Storage Explorer. You can go ahead and utilize Azure Storage Explorer, which we had downloaded in the first section. Both work the same way. Inside the storage service, under the tables, you can see that there is a table, messages, and there is no data available currently in this table. So what we will be doing is, we will be submitting the content. It just returns saved. We can go ahead and modify this as well as needed, but since this is just an introduction, we don't need to do that. Head back to the same tab for the Storage Explorer, and you can see that a new tuple has been saved with all the information which came from that form. So this is a very simple way to create a contact page that your customers can use to send you some message requests without you having to provision any website or any containerized package for this. It works in a very serverless fashion because all of these services are managed and provisioned by Microsoft Azure, the Azure Functions, as well as the storage service. However, a couple of things are missing from this service. First and foremost is the security. Azure service does not support these SSL certificates to be installed, so you will be missing out over here. And since we are using a service which is going to take some input from the customers, it is going to be the worst solution to be deployed if not utilized behind an Azure CDN, because Azure CDN supports the SSL certificates, whereas the Azure Storage Service does not. And we also did not integrate any email service to notify the developers as well. So now in the next video, let's go ahead and take a look at how email communication services can be integrated in your PaaS solutions. Let us go ahead and study how email integration can be made in PaaS. We studied that basically all PaaS components support some connectors in the form of REST API or socket communications or normal EDI. Two-way binding can be configured for the cloud services, which means that both of your services can accept some information and can provide some information for other services to function properly. And this enables services to interact between each other and to provide a common solution for the customers. Most of the email providers include, but are not limited to, Microsoft Office or the SendGrid. I have used both of these services. SendGrid basically supports 25,000 emails per month for free. Any Azure subscription holder can create a free account and can receive this quota. It also supports delivery dashboards, so you can go ahead and review how this email quota is being utilized, which of your customers have read the email and which have not. Speaking of the customers, let's go ahead and take a look at how you can configure the services where your customers can send orders or requests to your developers or the customer support in the next video. When it comes to managing the orders or requests by customers, Microsoft Azure provides you with a couple of options which you can use inside your solutions to support these options. For example, you can utilize the queue storage and store the messages inside the queue instead of having to deploy your own applications and manage a time-based message parsing or message notification system.
You can also use the tables, which can be utilized to generate the reports for all the orders that a customer has on your system. And these are the services that fall under the platform as a service category, using which you can deploy your own solutions on top of. However, we recommend that you utilize the Azure Cosmos DB. Azure Cosmos DB supports single-digit read operations, which means that you will always be providing a very fast response back to your customers. The Azure Storage Tables can be replaced with Azure Cosmos DB, and Azure Cosmos DB supports the premium Azure Tables, which have some better SLAs as compared to the normal Azure Tables. You can also utilize other services of Azure Cosmos DB such as the MongoDB or the Document DB for NoSQL messages or reports that you have to generate. And it is the most scalable and efficient solutions provided on the Azure under the PaaS category. Then within these services, you can also add a couple of more options depending upon the type of service that you are deploying. You can even go ahead and target your own ERP solutions for SAP or your own custom deployed solution. You can also add machine learning capabilities to the API management for the purposes of security or to provide personalized responses to the customers. For example, you can include the sentiment analysis to determine whether the request of a customer is from a happy customer or from an angry customer, so that you can forward their request to the respective department. You can also go ahead and build chatbots on top of these APIs so that your customers can communicate with the service and have their operations performed, such as placing an order for an item, requesting the status information for an order that they have already placed, or to cancel an order. You can also go ahead and integrate the push notifications to engage your customers for a new marketing campaign that you might have. These are a couple of options that you can go ahead and try out on your own. We will now go ahead and take a look at how you can automate the frequently asked questions page for your website using the Azure Q&A or the Q&A Maker in the next video. Now let's go ahead and automate our frequently asked question websites or the pages using the Q&A Maker or the Azure Q&A. For any customer-facing web application, the facts pages are the most visited pages by any customer. Customers would either ask via calling directly to your customer support helpline or sending you an email, or they would go ahead and read the frequently asked questions to learn a bit more about your service. Frequently asked questions are hard-coded questions, and their answers are specific to that particular question only. Most of the times, it is quite difficult for your users to know where that question has been asked. Most of the times, they just scroll around the web page and they don't find the answer for the question that they have. I personally believe that the easy facts are the facts that are done right. So for example, if your user can quickly go ahead and read a question, get an answer, that is the fact that basically your users are going to love and enjoy reading and sharing with other friends as well. And that is where Q&A Maker comes into the scene. Your Q&A Maker can take any source, whether a URL, a JSON document, a Word file, an Excel sheet of questions and answers. It can then go ahead and sort, rank, and order all those questions and build up its own machine learning model of questions and answers. It can then go ahead and utilize the Microsoft Bot framework and provide answers to your customers. You can go ahead and read more about the Q&A Maker on this link by Microsoft. To take a really very quick overview of how this service can be deployed, let's go ahead and create a new service for the Q&A Maker. Let's head back to the Azure portal and create a new service. We will search for Q&A. Q&A Maker will be the response provided by Azure. You can go ahead, create the new service, fill in the details for this service, and once done, you can create this resource. Most of these values, such as the pricing information, can be easily studied on the pricing pages for these services. Once done, create the new resource, and Azure will go ahead and deploy a new cognitive service on the cloud for you. Once deployed, let's head back to review our service. Under the overview page, you will find out a bunch of information for your service, such as the endpoint, the pricing, etc. Let's head over to the Q&A Maker website, the qnamaker.ai. Over here, you will be provided with a couple of options such as your knowledge bases and an option to create a new knowledge base. Head over to that tab. Step 1 is to create a new Q&A service on Azure portal, which we have just done. Step 2 is to connect your Q&A service to your knowledge base. We will go ahead It will be different for you, so you can check out the values for these options inside your own portal. Next, we will provide a name for the service if you want to configure it. Since we do not have any frequently asked questions URL link, we will skip this. Finally, create a new service. It will create a new knowledge base for you and provide you with a tab where you can add new question and answers. Let's go ahead, enter a couple of questions and answers to each of these questions. And once we're done with this, we can go ahead and train the model. Saving and training is basically the knowledge-based learning from our questions and answers. Once done, we can go ahead and test the service, input a sample question, and wait for the Q&A service to provide us with a response. As you can see, Q&A service basically goes ahead and provides us with a response. And that is how easy it is to basically utilize the Q&A maker. But you must know that there is no machine learning behind it, so your Q&A maker does not know the context of a user. So it will only provide you with the answers that it has been trained for. Now let's go ahead and publish the service. Under the Publish tab, click on the Publish button, and it will take a couple of minutes and publish your service on Microsoft Azure. Once done, it will provide you with a bunch of information for your service, such as the endpoint, the host, the authorization method, the content type that you must be using while deploying the service, and the payload schema. Let's go ahead and inside the Postman, copy and paste this information and send a request to that endpoint. And as you can see, providing all the headers that were necessary, I was able to send a request and get a response. You can utilize your own HTTP clients, for example, for C#, and explore this option and provide a service to your customers where your customers can send a request over to your website and your website will have Q&A maker provide a response to your customers. So that is pretty much it for the Q&A maker. It's a very simple service to be deployed. Now in the next video, let's go ahead and take a look at the Azure functions and the Azure logic apps and take a quick overview of what are the major differences between these two services, since they are both serverless and they both support binding and trigger-based flow management. For the last video of this section, let's go ahead and take a look at the differences between the programmable serverless approach as well as the graphical managed serverless approach. The overall difference between the Azure functions or the Azure logic apps is that Azure functions basically provide some scripts that you can edit to provide your own functionality, which means that you can modify the way the function executes. Whereas in the logic app, it's basically a visual workflow editor that you can use to modify the chaining of the events, and you cannot modify what those events actually do. But the overall benefit of the Azure logic app is that the connectivity between the events and the triggers is quite simple. It's a couple of clicks only, whereas in the Azure functions, you're also provided with a limited number of bindings that you can use to capture the input, and there are limited number of triggers that can be used with Azure function as well. From the operational standpoint, we can see that Azure functions are serverless, so the scale management is not a concern at all, whereas the same goes for the Azure logic apps as well. For monitoring, Azure logic apps utilize the Azure Monitor, which is an IaaS level monitoring service by Azure, or it supports the analytics within the portal using the Azure Monitor itself. Azure Functions, on the other hand, also supports the application insights because it can support the programmability of the components as well. The Azure logic apps can be programmed or written a script for using the PowerShell development as well, whereas Azure Function does not support that. Azure logic apps also support a much safer, a much stable, and resilient experience for business-to-business communication because most of the services or components are written following the enterprise security practices. The downside of the Azure logic apps is that they only run in the cloud, so there is no on-premises alternate to the Azure logic apps. So you always have to deploy all the services and the solutions or the workflows that you have developed for Azure logic apps on the cloud, which is the Azure itself. Now, let's go ahead and quickly deploy a new logic app and see how it works. On the portal, search for a logic app and create a new logic app. You can read the introductory information for the logic app or head right into the creation phase. Input the details for the logic app, and once done, you can just go ahead and create the new resource. You can also see that it supports log analytics, which is an IaaS level monitoring service, and it also provides the capabilities to generate reporting for different aspects of the metrics that are collected. Once done, open up the service. The Azure portal will automatically take you to the Logic Apps Designer, which is the online or in-portal component provided by Azure, which allows you to develop and design your Logic App workflows. Basically, you start up with a trigger. For example, when a message is received in service bus queue, when an HTTP request is received, or more. You are also provided with a couple of templates which are pre-configured workflows, and you can input your own fields, you can attach your own services, and you're done. We will go ahead and utilize a trigger, for example the HTTP request trigger, and create our own logic flow on top of it. We can configure these properties, we can validate how the request body should be, or we can go ahead and add next steps to this flow. For example, we will go ahead and select that we want to respond. However, we are also provided with a couple of more options, such as a conditional block to verify that a condition is met on the request. Let's first go ahead and review a couple of options which are available. So in the built-in option, we have a response that can be used to respond to the user. We will just go ahead and input caught a request in the body, and that's it. Since we only need to just test the logic app itself, we can go ahead and also include more steps. So for example, if we want to perform other actions like storing the request information inside the table or doing other stuff once the user has been notified, I will just go ahead and modify the response step, save the logic app. Now let me go ahead and copy the URL and send a request to it. It will not be accepting any GET request, so I will need to send a POST request. I will go ahead and open up the Postman, and inside the Postman I will input the URL which is necessary to send the request, and I will be sending a request to it. And as you can see, it provides a response caught a request which we had already sent into the logic app. And that is how quickly and easily we can deploy a complete logic app itself. We can deploy a workflow on top of Azure services itself. These are all serverless applications, and they will only be triggered if they receive a request. And depending upon other triggers, they will also only be triggered when there is some information in it. And as you can see, since it does not require any programming, it is quite easier to manage and deploy. So that was pretty much it. To summarize, in this section, we went ahead and discussed a couple of serverless options offered by Microsoft Azure. We took a look at the Azure Functions, the most notable serverless deployment approach provided by Azure. We also took a look at how message delivery services can be integrated with other components on Azure, such as SendGrid or Office 365. We also went ahead and took a look at a couple of more options, such as the Q&A maker, and we saw how we can create a machine learning based frequently asked question page. Now, in the next section, let's go ahead and discuss a little bit about the security on the cloud.
So in this section, we will go ahead and take an overview of how we can deploy the services and also try to secure them as much as possible while staying inside the platform as a service category. So in this section, we will be taking a look at the service Azure Active Directory, or in short Azure AD, and we will see how it quickly and easily integrates with the app service. We will then go ahead and take a look at how B2B or B2C communication is made possible using Azure Active Directory, and we will also discuss a couple of features of Azure Active Directory SDKs. First off, let's go ahead and take a look at why authentication is necessary on the internet. When your solutions are deployed on the public internet, security is needed, not just to prevent hackers from submitting malware to your applications, but also to provide a verification model for your customers so that they can know that the service that they are using is the service that they know that they have to be using. For example, if you provide a simple message sending service and the service is not secured using HTTPS, or your users are not authenticated, then it causes an alert in the minds of the users that this service might not be the service that they want to be using, because their data can be leaked to anybody. And even if the hackers do not leak it, it might be that your users and their data gets compromised in the midway, and the primary reason is that most of your on-premises protocols or the standards, they fail on the internet. On-premises protocols are designed for the data centers where the data stays inside the data center and no external access is provided to the services deployed. However, that is not the case on the internet. Although hybrid cloud solutions are also available, but most of the times your employees or the customers, they are always on the go. So you definitely need to provide a solution using which your customers and employees can connect to the services while they are on the go using their mobile devices, their tablets, or a public internet cafe as well. And this leaves the responsibility of security and data protection over to you. So you have to make sure that everything that is published to the internet, especially to your own services, you are responsible for ensuring that the data is protected using SSL or other similar features, and also that the data gets cleaned up or wiped off from the services that are deployed for the clients to use, such as your web applications must not cache or store any information on the client's machine because client might be using a public or shared machine. Most of the times, cloud vendors also provide an AI or machine learning based models that can help you in determining when account of a customer or your employee has been compromised and you can take an action on it. A couple of services that Azure AD supports include but are not limited to business communication as well as the services for B2C communication. For example, Microsoft Azure Active Directory supports OpenID as well as OAuth protocols so that you can utilize the services for authorization as well as authentication. And you do not need to rewrite your applications to support Azure Active Directory as it will automatically integrate with your own components. And that is where the native SDKs come into the play. Native SDKs are made available for server applications as well as for the client applications so that you can control how your users authenticate and how they access the data on the applications. And it also supports identity services for your own Azure resources that have been deployed on the cloud so that each individual resource has an identity when it is trying to communicate with another resource to fetch some information or the data. Apart from the services that Azure Active Directory has to offer, another very important feature of the Azure Active Directory is that it is globally accessible. Your users or the customers can access their information and utilize their identity services anywhere on the globe. So they do not need to connect to the data centers through a VPN or anything. And this also provides a similar feature to your operational teams. So inside the Azure portal, you are provided with a singular dashboard that can allow your IT or the NOC teams to control how users are accessing the resources and which of the users need to get an access key for the services or the access of which of the users needs to be revoked. For enterprises, Azure Active Directory also supports custom branding, which means that you can match the theme of Azure Active Directory with your own theme, and you can also include your own logo to make sure that the customers know that this is indeed the service that they want to be using. Most of the times, it is thought of that the Azure Active Directory is just a revamp of the Active Directory that we know from Windows Server, and it has been deployed as a cloud solution on the Azure. Active Directory is pretty much older product, and internet as well as the security protocols have changed quite a lot over the time. And that has helped Microsoft in redesigning the overall architecture of the Active Directory and to deploy the best-in-class security and protection protocols on the cloud. Azure Active Directory powers authentication on Microsoft Azure services. It also helps consumers or customers of Office 365 to utilize most of the services from Azure Active Directory to support the data protection. And whenever you buy a new subscription with Azure, an Azure Active Directory is enabled for free. So you always have a new tenant inside the Azure Active Directory. Last but not least, Azure Active Directory is able to provide you with identity management and control for all of the resources as well as your employees. And not just the employees, you can also include external contributors to your own services and provide them with access, as we will see in the later videos inside this section. So we will take a look at the couple of features provided by Azure Active Directory, such as how authentication works inside the portal as well as on top of other resources. We will also go ahead and take a look at how we can integrate the Azure Active Directory services inside the Azure App Services. We will also discuss what are the benefits of integrating the Azure Active Directory SDKs inside our applications. Before we actually head over to the demonstration of Azure Active Directory, let's go ahead and try to study What features does Azure Active Directory has to provide us for the identity management on the cloud? Azure Active Directory has made identity management on the cloud really very easy, whether it would be for the applications, for users, for external contributors, for your consumers, for anything. Azure Active Directory has a solution for each of these scenarios. Azure Active Directory supports native B2B as well as B2C identity management, and you can utilize the services such as application integration to provide native solutions for organizational communication. You can also involve external contributors without having to add them inside your Active Directory or having them being federated from their own Active Directories. You can provide them with a one-time password, or you can include them within your Active Directory for a limited time. For B2B consumers, Azure Active Directory basically supports external profiles that they can maintain on their own external services such as Facebook, Google, or any other service that supports OAuth or OpenID profiles. From data protection and security standpoint, Office 365, for example, supports data protection and secure removal. So for example, if you have just shared a report with an external contributor, you can go ahead and remove the access for the external contributor, and that file will be locked for them. Azure Active Directory also supports hybrid communication so that your on-premises Active Directory can communicate with Azure Active Directory and synchronize the contacts between both these Active Directories. Another interesting aspect of Azure Active Directory is that it supports multi-factor authentication, so your users can authenticate themselves using phone, using a one-time password, using authenticator applications, and so on. For B2C consumers, Azure Active Directory SDK for iOS, for Android, and for other native client runtimes and platforms enables your developers to integrate Azure Active Directory components to securely authenticate your clients and authorize them as needed. Azure Active Directory supports both OpenID as well as OAuth 2.0 protocols. So this enables your developers to control what data do they have to provide to the application so that it can perform properly. And you can also go ahead and remove the access to the applications from within the portal. And as we will see in the later videos, Azure Active Directory supports out-of-the-box support for most of the identity providers such as Google, Facebook. In fact, the Azure Active Directory support is provided just a click away. And not just normal identities on the Azure, but Azure also supports managed identities on the resources. So, for example, you can create a separate identity for each of your individual resources, such as if you have an app service, it can have a separate identity on the cloud, and it can communicate as a separate identity with other resources and request data or share data. And this also means that you can provide access to each individual resource to external contributors so that they can access the resource, modify it, and make changes, but they won't be provided with access to any other resource within the region or within the resource group itself. And all of that is done using the Azure Active Directory identity. And for your operational team, they can control this via the in-portal support that is provided, or they can use the REST API SDK for the Azure Active Directory and maintain and manage all of these services from over there. So now, let's go ahead and quickly integrate the Azure Active Directory with our Azure App Service. So now let's go ahead and quickly integrate Azure Active Directory services with our app service to enable authentication and authorization of the users on the Azure App Service that has been deployed, which does not contain anything irrespective of the security or authentication of the users. Let's head back to the Azure portal and try to access the app service that we have deployed. As you can see, the application is accessible on the public internet. We can scroll down under the settings and access the authentication authorization tab. You can see it has been currently turned off. We can turn it on, and as you can see, currently it allows anonymous requests. It takes no action and it provides no security on top of the applications. Everybody can access this service and they are not prompted to log in. We can go ahead and change this action and select the type of authentication provider we would like to use. As you can see under the drop down, a couple of options are provided: Azure Active Directory, Facebook, Google, Microsoft account, or Twitter. These are the out-of-the-box solutions that are provided for us that we can utilize right away. We can also configure a couple of more options within our application, and that is where native SDKs will come into the play. However, we will just go ahead and select the Azure Active Directory. Just go ahead and click on the Azure Active Directory. It will open up a new blade for the configuration of Azure Active Directory authentication. As you can see, currently it is set to off. We can utilize the express settings, which only asks us to verify a couple of options such as the selection of the Active Directory as well as the selection of the application which will be used to authenticate our users on behalf of this application. As you can see, we will just go ahead and create a new application instead of selecting an existing Azure Active Directory application. One more thing, when you will head over to the Advanced tab, you will have to configure a couple of more options inside this, and as we had promised that we will only be utilizing a couple of mouse clicks, we will leave these settings up for the Express and just click OK. Once you have clicked OK, as you can see, Azure Active Directory has been configured for you, and now you can go ahead and click on Save. Once you click Save, Azure Active Directory will create a new application with the name that you have used, and it will enable Azure Active Directory on top of it. So now we will just go ahead, copy the URL for this application and open up a new private browsing window and visit the website that we have copied the URL for. It will load up, and as you can see, since we have not currently logged in, it redirects us to the Microsoft login page. Basically, this will be different if you have configured a different authentication provider. I will go ahead and log in with my own account, and once I'm done with that, you will see that it will forward me to the application itself. And now the application itself is trying to authenticate me for this application. It shows the application name, the permissions that it requires, as well as it asks for permission to verify that I want to authenticate this application on behalf of me to check my credentials. And once that is done, I will be authenticated and I will be provided with the application since I am authenticated and I am a part of that Active Directory which was used to authenticate the request. If I would use another account, even for Microsoft, that won't work because it will not be a part of the Active Directory that was used to authenticate the request for this website. Now, that was a very simple overview of how we can integrate the Azure Active Directory inside the app service. Now let's go ahead and see how we can invite external contributors and grant permissions to them to perform certain actions in our own applications. Invite external contributors and grant permissions to them to perform certain actions in our own applications. We will go ahead and add a new role assignment, and we will select the role for the new external contributor. There are several categories for the roles such as owner, contributor, reader. We will select the contributor role to provide a couple of options to the external contributor. Now I will go ahead and select external account for myself, and I will provide access to this. I will select this account and save it. What this will do is it will generate a new token and it will send over an email notification to my external email account. Just note the fact that that external email account is not a part of this Active Directory. So that account does not have the access to this subscription. If I log in with that email account into the Azure portal, and if I visit over the account information, you can see under my permissions tab that I have access to Visual Studio Enterprise. However, the access has only a single role, which is contributor, which we just assigned from that application, and I have access to the resource managed identity application, which we have created for this section, and I do not have any other permissions on the Azure service itself. But if I head over to the app services, you can see that I already have the managed identity app and I have the full control over this application. I can start, stop, restart this service. I can even delete the service, get the published profile for it. I can even review a couple of more options such as what are the stats for this website, how many requests, how many failures, and so on and so forth. So this is how we can basically introduce the users or contributors from external organizations without having to provide them an account inside our Active Directory or without having to provide them with an access token to the services. The benefit of this way of including the external contributors is that we can control for how long that they remain in our Azure resources, and we can also customize the permissions that they have over each of the resources. And so that is pretty much how you can quickly and easily invite external contributors inside your own Active Directory. Now let's go ahead and discuss Just a couple of benefits that you can get once you integrate the Azure Active Directory SDK inside your native applications for client or server management. Once your requirement for the security or identity management exceeds the basic level of support provided by Microsoft Azure, you can head over to the native support by Azure Active Directory and you can integrate the native SDKs inside your runtime. The hosted Azure Active Directory provides the machine learning based policies, and Microsoft manages all those policies for you, and they can alert your operational team whenever there are some problems or some suspicious activity going on for your directory. It supports user flows to support registration, logging, authentication, or authorization of the users. The hosted version of Azure Active Directory is a SaaS model service because you do not have to write code for anything. And it supports single sign-on for various runtimes as well as for various platforms. The native SDKs come into the game when you want to extend the functionality and the services provided by Microsoft Azure. Azure Active Directory SDKs are available for basically most widely used runtimes or frameworks for .NET Core, for Node.js, Java, Python, Go, Ruby, PHP, and God knows what. It allows your developers to write the code that can provide easy integration of Azure Active Directory within your own applications to provide native support of authentication as well as authorization. And it allows your users to control what data is provided to the user and what data is captured from the application. And it has a better user experience since your clients only have to use one single application instead of being redirected to other applications, whether native applications or in-browser redirects to other applications for authorization purposes. Azure Active Directory has native support for the SDKs. For example, it has support for Node.js, for .NET, for .NET Core. It also has client-side libraries written for Java, Python, even for Android and iOS, so that your users can connect with the identity servers and can continue with their work. And just like the Graph API of Office 365, Azure Active Directory also have a Graph API. Graph API basically is a RESTful API for cross-platform support so that you only have a dependency on an HTTP client in your runtime and you can utilize everything that Azure Active Directory has to provide you with, such as creation of a user profile, deletion of a profile, modification of a profile, and so on. It also allows you to create or manage the permission scopes to control the data flow between the applications or from the user over to the application. And that is pretty much how the security using the Azure Active Directory is managed on the cloud. And so now this brings us to the end of this section. In this section, we went ahead and took a look at what protocols are supported on Microsoft Azure for your applications, such as OpenID, OAuth 2.0. We also took a look at how we can explore the Azure Active Directory service inside the portal. We also took a look at how we can integrate the application service inside the portal so that we can integrate the services such as Azure Active Directory and Azure App Service. We also took a look at how we can invite and manage the external contributors, all using the Azure portal itself. In the next section, let's go ahead and take a look at how automation inside the platform as a service category works and how we can utilize the services or solutions provided by Azure to support our DevOps environments. So now that we have explored a couple of options for security, for the data storage, for persistence, and for the serverless deployment of the solutions, now let's go ahead and take a look at how our solutions and their development or deployment can be automated on the Azure platform and how we can integrate these services inside the DevOps environments. So in this section, we will go ahead and take a look at the overall Azure automation, which is definitely an infrastructure as a service level solution by Azure. We will then go ahead and understand the concept of infrastructure as code, which will bring us to the topic of Azure Resource Manager, which is the solution by Azure for infrastructure as code management. And from there, we will go ahead and discuss the Azure DevOps as a service and take a look at how it can help us automate our deployment processes. First off, let's go ahead and try to explore what infrastructure as code actually means. To understand the concept of infrastructure as code, one first has to understand what it means by the code in the term. By the code, what it means is that your deployment template basically is a serialized representation of your overall infrastructure, which contains different resources such as the virtual machines, the storage accounts, your virtual networks, your VPNs, your gateway information, as well as the configuration for your virtual machines. The serialized format for the overall infrastructure basically is stored as a JSON file or YAML file. Other tools might have their own format for the storage. Some might even have a scripted format for the storage of the resource template, but we will be focusing on the JSON templates that are used by Azure. So if we try to cover up the infrastructure as code, it's basically used to version control your infrastructure as well as the configurations used in each of the version of the infrastructure. This means that the overall profile of your infrastructure, which is deployed on the cloud or on premises, is stored as a serializable data such as JSON or YAML files. It enables your operational teams to version, label, tag, and share the infrastructure within the team or within the organization. This also enables you to store an active state of your infrastructure so that you can roll back to a previously deployed state in case you ever find some issues with the current deployment state. There are so many tools that are available to perform these actions such as Ansible, Chef, Puppet, even the custom tools that are deployed and are available on a specific vendor such as the Azure Resource Manager. Since we are talking about infrastructure as code, it would be a very best practice if your infrastructure as code template is platform agnostic. There would be no benefit in the infrastructure as code management if your infrastructure is only deployable on a specific vendor. So you must always go ahead to a cross-platform solution. Also, your infrastructure as code template must be human readable. So when it is stored in the string format, such as in JSON or YAML, a developer must be able to configure these settings himself without having to depend upon a tool to be used. It must be easier to revision or version your infrastructure so that your operational team can study the overall behavior of resources inside the infrastructure. And since we are talking about the revisions, your infrastructure as code template must also be very easier to roll back any changes that were not necessary or that have broken your overall infrastructure performance. It must also be deployable on each of the cloud vendor, so it must not be depending upon a cloud vendor itself or the hardware that can accept the solutions. Last but not least, it must also have some support either from community or from the product developers themselves so that you are not left out in case you ever face some issues with the overall product development as well as the deployment. And on Microsoft Azure, we have Azure Resource Manager, which is provided out of the box as a solution and has its own template for infrastructure as code management. Let's go ahead and take a look at the Azure Resource Manager. Azure Resource Manager is the Azure's take on the infrastructure as code service, and it's basically the infrastructure management tool by Microsoft, and it is supported on Microsoft Azure. The overall purpose of the Azure Resource Manager is that aids you in the resource management, orchestration, as well as operation. All the modern solutions which are deployed on Azure utilize the Azure Resource Manager for the grouping of the resources as well as for the deployment, for upgradation, or for deletion of the resources when they are no longer needed. And we have also explored in initial sections, and we always keep on recommending the same thing, that you must create a separate resource group for every service so that once you have to delete the services, you can go ahead and delete the resource group, being sure of the fact that each individual resource will be deleted. Internally, Azure Resource Manager uses JSON notation to store the infrastructure profiles, and it utilizes those JSON notation documents to deploy your services on Azure. The template is basically human readable, and you can develop the template using text editors. And Microsoft has provided extensions for Visual Studio Code, and you can use these extensions on Visual Studio Code to write your own templates for Azure Resource Manager and to deploy those solutions on Azure as well. And this mode of the service grouping helps Azure solution developers to group their resources within the resource groups, and a resource group is able to define the location of the deployment. It also controls the policies at the resource group level. It can help the developers to tag their services, manage dependencies, as well as the state of the resources, all from one single page. So, for example, the overall information about the group is displayed collectively, such as the billing information, the deployment statuses, or other information. Here is a resource group of my own that I have deployed on Azure for over a couple of months. And as you can see, we can explore a couple of options such as the resource costs that are associated with this resource group, and it will show us overall charges for the entire resources within this resource group, and we can explore and drill down each of these resources. It also shows us the deployments that we have made within this resource group and which of these deployments have passed or failed. We can also go ahead and take a look at the policies that have been enforced on this resource group, and we can also explore the template that this resource group actually has, which is the ARM template, which we will be covering in the later parts of this section. But first, let's go ahead and create a new template deployment. Let's go ahead and take a look at what ARM template basically looks like, and then we will go ahead and generate the template for existing resources in the next video. Let's go ahead and create a new template deployment. The template deployment basically is just like another service on the Azure cloud. We go ahead and create a new resource. We search for template and a new service will be shown to us, such as the template deployment. You can go ahead and study a couple of options such as the documentation about the template or utilize the common templates. So for example, let's go ahead and deploy a new web application. As you can see, a new template has been opened up for this resource. There are a couple of parameters, variables, resources, and a complete JSON document that controls the overall infrastructure for this. Under the resources, you can explore a couple of options. You can also go ahead and add a new resource. Under the resources, you can select the resource type that you want to create. For example, if you want to create a new storage account, we will provide the name of the storage account, and as you can see, it will be the storage account under the resources. And that is how the overall template works. We can go ahead, save this template. Even we can purchase the resources that we have created inside this template. Selection of the resource group. These are the same steps that we have been taking in the previous sections, and we will continue to take in the later modules as well. Now that we have explored what Azure Resource Manager template looks like, let's go ahead and deploy a new template on our own. You can find out a couple of samples for the Azure templates on this link at GitHub, which are open sourced by Azure and are available for you to utilize and deploy on the Azure, or even you can go ahead and modify them and take a look at how the template editing extension works. So that is how the ARM template basically looks like. And so now let's go ahead and generate a template for our existing resources. So having seen the template for ARM on the Azure, let's go ahead and try to generate the ARM template for an existing resource on Azure. Let's head back to the resource group that we were exploring and click on the export template. Once you click on export template, Azure will generate a template for you, including the parameters, variables, and all the resources that have been created inside this region. It will take a couple of minutes, and once done, it will generate the template for you. And as you can see, around 14 resources that are deployed in this region and 8 parameters that can be used by the users or the consumers while they are deploying the services. You can go ahead and download the template, or you can also save the template on your online library so that you can deploy the same template once again. Saving the template requires a name and a description, and then you can go ahead and save the template. You can also select to deploy this template once again, and once you click on the deploy button, it will go ahead and ask you the similar questions it asked us the last time, but this time it will have a couple of more options as well as resources. But the overall process is similar to what we had experienced in the previous video. The resource deployment will just take your consent to deploy these services and purchase the solutions from Microsoft, and once done, it will go ahead and deploy the services on the cloud. And that is pretty much it for how it works using the ARM templates. Now let's go ahead and take a look at how we can utilize the Azure DevOps or other automation tools to deploy the services on the cloud. The Azure Automation Service is an infrastructure as a service level solution provided by Microsoft, which enables developers and operational teams to manage the overall automation of the services. Azure DevOps is a complete cloud-hosted DevOps solution which focuses on the development and operational sides of your solutions. It enables developers to ship updates quickly because there is an end-to-end pipeline solution that is configured by Microsoft, and it can be configured by the developers themselves so that their code, once committed, reaches the production code in no time at all. Azure DevOps also supports team communication via issue boards such as the Kanban or product backlogs. In other terms, Azure DevOps is a complete suite of continuous integration as well as continuous delivery. It is cloud hosted and you can maintain and install the product on premises as well. Azure DevOps is not as much powerful as Azure Automation Service provided by Microsoft, as Azure Automation manages the overall infrastructure. Azure Automation can control the virtual machines, networking, even your internal processes that are running on the virtual machines as well. Azure DevOps, on the other hand, is not a service of Azure, although it is hosted on Azure, but it's not a product that you can purchase on Azure Marketplace. Rather, it's basically a revamp of the Visual Studio Team Services, which was actually Visual Studio Online a couple of years back, where Azure DevOps focuses on the development of the solution as well as building, testing, packaging, and deployment of the solutions. Azure Automation focuses on the processes and resource automation so that anytime your resource fails, Azure Automation will kick in and try to redeploy it. Azure DevOps is basically a tool for DevOps on Microsoft products as well as for open source communities. A couple of differences between the Azure DevOps as well as the Azure Automation are that Azure DevOps does not support cron jobs, so you cannot run build or deployments using cron jobs. You will always have to depend upon other services that are provided by Microsoft Azure or the DevOps protocols such as the Git. We will not go into the depth of the Azure DevOps because we already have a course which focuses entirely on the hands-on development of DevOps solutions on top of Microsoft Azure, and you can explore that course and learn more about how DevOps happens on top of Azure platform. And before we wrap up this chapter, let's go ahead and take a look at how you can secure the template file. Although your template file has to rely upon the parameters that have to be passed in by the users, you can also go ahead and enforce a couple of options that can enable your template files to be secured. First and foremost of the options is that you must always keep the sensitive information out of the file, just the way you should always configure your application to read the information such as the connection string from the environment settings instead of having to hard code the values inside the code and then check it in to the version control and leave your sensitive and private information exposed over to at least your own organization. You must always keep the sensitive information such as the variables, the data connection strings, or your keys outside this file. And you must always use the parameters to ask for input, and users can go ahead and include the value before they deploy the solutions. And you should always utilize the secure string value for the parameters value type whenever possible, so that Azure can take care of the rest of the security policies and data protection as needed. So this is pretty much it for the ARM templates. In this section, we basically went ahead and took a look at the infrastructure as code. We studied the Azure Resource Manager as well as the Azure Resource Manager templates. We studied how Azure Resource Manager template can orchestrate the services and maintain the infrastructure, structure, and state. We also went ahead and discussed a couple of options such as continuous integration and how continuous deployment or delivery can be managed on the Azure solutions. Now, let's go ahead and take a look at how we can manage the networking of our solutions and how we can control the network flow on our applications using the Traffic Manager. Now that we have covered everything regarding the compute as well as the storage of our applications, let us go ahead and discuss the networking side of the Azure solutions. In this section, we will go ahead and take a look at the Azure networking, the overall concept of the infrastructure as a service level networking. Then we will go ahead and introduce traffic management using the PaaS components such as Traffic Manager. We will also take a look at the load balancing for our applications in the PaaS category. We will also try to take a look at how disaster recovery or high availability of our applications can be configured using Traffic Manager. And we will also discuss how DNS management can help us out in this area. But first, in this video, let's go ahead and take a look at the basic components of the network, which are the load balancers or the network security, and explain how they work. On Microsoft Azure, the networking is done using the Azure Virtual Networks, and they are used to power up the entire infrastructure communication on and off the Azure. So your public, private, or hybrid solutions all will have to utilize the services offered by Azure Virtual Networks. And virtual networks support most widely used communication protocols such as IP-based communication. You can even create your own VPN networks so that your cloud only communicates with the on-premises and so on. And this also enables Azure Virtual Networks to support the hybrid clouds through the usage of Azure VPN or using the express route, provide the customers with the functionality of hybrid clouds. And all of these services come shipped with the security policies for the data protection or the web application protection, which is developed and deployed on the cloud. Just the way we discussed the Azure functions, in the similar fashion, let's go ahead and take a look at how our application receives a request and at which levels can we integrate some security policies. So at the first level, Azure Virtual Network controls the overall data center network flow, and it can be used to enforce policies throughout the region. Then within that region, we have a traffic manager which can control the flow of the traffic to one or more of our web applications that are deployed on Azure. And Azure Traffic Manager also supports traffic flow control for our on-premises solutions, which we will be discussing in later videos. And then Azure Traffic Manager then forwards the traffic toward our instances such as the Azure App Service. And all of these network services or solutions support firewalls that can prevent unauthorized connections, the way we just saw in the fourth section of this course by using Azure Active Directory. And Azure VPNs support the industry standard protocols to secure the tunneling between your on-premises as well as the Azure data centers so that only your on-premises can access the cloud resources. And other most commonly used protocols and specifications are also provided on Azure, such as the route tables, which can be used to forward the traffic to a specific instance by checking out the URL that they are requesting for. And the Azure Traffic Manager basically is a DNS level service which works as a complementary solution for your DNS services. So, for example, whenever your user sends a request over for your service, Azure Traffic Manager will work before that request or the host name gets resolved to an IP address. We will take a look at how it can help us load balance our solutions or how to maintain high availability for our services. And in most cases, you will only be needing the Traffic Manager to control the network flow for your solutions on the Azure. Now, in the next video, let's go ahead and create a new Traffic Manager profile and study how it works. Before we actually go ahead and create a new profile for the Traffic Manager, let's take a very quick overview of how this service actually works. Since we have already mentioned the fact that Azure Traffic Manager is a DNS level traffic control manager, it works inside the DNS service. So how it works is that you actually provide the host name for this Traffic Manager instead of your application. And that is the host name that your users will be sending a request over to. Once the Traffic Manager gets a request, it will resolve the IP address for the service that is best suited for the customers in that particular region. Traffic Manager also supports hybrid cloud solutions because it can automatically forward the traffic to on-premises or toward the solutions that are hosted on the cloud. Traffic Manager also provides out-of-the-box health monitoring solution for your services, and it automatically checks for when an endpoint is not healthy anymore so that it can forward the request to other endpoints such as your on-premises or on the cloud. The basic flow of the traffic is that whenever your users have to send a request over to your services which are hosted on the cloud or they can be on the premises, what happens is the Traffic Manager comes as a middleware and serves as a domain name resolution service. Your users will be sending a request to the Traffic Manager, and Traffic Manager will resolve the IP address for the actual service that has to provide the services, or the best services based on the performance, geographical location of the user, or the health of the endpoint. And once that is done, Traffic Manager gets out of the picture. And after that, the users will be directly communicating with your region, so there is no overhead for this service throughout the communication. And another major point of Traffic Manager is that it can be nested inside a Traffic Manager as well, so that if you have a region which has multiple services deployed, your users can first resolve the region which is best for them, and then they can go ahead and resolve the app service or the solution which is best for them based on the routing or based on the performance or health of the solutions that are deployed. And so this way it provides a very customizable solutions for your developers to develop and deploy the solutions on top of. Let us go ahead and create a very simple Traffic Manager profile. You can search for the Traffic Manager profile on Azure and create a new profile. It will ask the most basic information such as the name of the service, the routing method that you are going to be using, the subscription where it has to be deployed, the resource group that you have created, and that's it. Go ahead and deploy the solution, and then we will go ahead and include some endpoints inside the service. On the overview page, you are provided with the DNS name for this service that you can use to provide to your customers, who can then go ahead and access the resources that are deployed behind this profile, the monitoring status, the routing method that has been set for this service, and so on. Let's head over to the Endpoints tab and add a couple of endpoints. I have deployed a few Azure resources. As you can see, the types of the endpoints are the Azure, the external endpoints, which are your on-premises endpoints, or the nested endpoints, which are the nested Traffic Manager profiles. You can provide the name of the endpoint, select the target resource type. The resource types are the app services, the cloud services, etc. Then go ahead and select the resource. We will select a resource from West Europe and apply a weight to it, let's say 10. And if you want to apply a custom header setting to provide to your application, you can provide that over here as well. Once the endpoint has been saved, let's go ahead and add another endpoint to the same service. Following the same pattern, we will provide the name app2, select the resource, and select another service within the West Europe resource group. Add a weight, and you're done. And when you try to save the service, you can say that it failed. The reason because it failed is that both endpoints cannot be in the same region. The point is that Azure Traffic Manager has to forward the traffic within the regions, and if multiple endpoints are configured for the same region, it will fail to do so. And it also depends upon the profile that you are currently using. So within the weightage profile, you cannot have multiple applications deployed in the same region. Let's go ahead and add a new application from a different region and see how it works. Let's go ahead, call this application app3, apply the weight, and save it. And as you can see, it has saved the endpoint. It is currently monitoring the application, it is checking the endpoint. One more thing to notice over here is that the applications to be deployed with the Azure Manager have to be at least at standard tier. Lower tier applications are not supported by Traffic Manager, and if you have added an endpoint and then you try to modify its pricing tier, it will fail to forward the traffic to those endpoints and it will consider it as a non-healthy endpoint. Next, let's go ahead and try to see how we can configure the applications. As you can see, there are a bunch of options such as the port, the path, the custom header settings, and the expected status code that your applications have to submit. For example, the default is 200. You can provide a range such as 200 to 299 and so on. And then you can also configure the fast endpoint failover settings, which basically is a service of the Traffic Manager that continues to poll the status information from the endpoints, the probing interval, the probe timeout, the tolerated number of failures before the Traffic Manager labels the endpoint as non-healthy and starts to forward the network to other resources. So that is pretty much it, how the Traffic Manager basically works. Now, let's go ahead and in the next video try to take a look at how we can actually load balance the traffic between these app services. To enable load balancing functionality between our applications, we can utilize the Traffic Manager and deploy a load balancer between the applications on the premises or on the cloud. Load balancing is done based on the traffic load on the applications or the geographical location of the users who are visiting your applications. Traffic Manager profiles can also check the endpoint health to determine whether they can serve the requests or whether the request has to be forwarded to another endpoint. A couple of options for the load balancing include the wait or the priority application to the endpoints. Let's now head back to the Traffic Manager profile, and under the configuration we can see that the routing method currently has been set to waited. There are a couple of routing methods supported by Traffic Manager profile, such as the performance, weighted, priority. Among these, I personally believe that you can use performance or weighted for load balancing solutions. The priority will always provide priority to a single instance. Geographic basically will support the nearest location of endpoint to the users, and so on and so forth. Now, I just went ahead and created these services on the Traffic Manager profile. As you know, that Traffic Manager profiles are basically DNS based, so a couple of DNS caching problems can occur. So if you have just modified the weightage of the service or the priority type of the services, it's going to take a couple of minutes before these changes propagate to your users, because the DNS level caching happen on the DNS, it happens on the operating system, it happens on the browser, and so on. So let's go ahead and head back to the overview tab, capture the DNS name for the service, and send a request to the service and see what it provides us with. As you can see, it is generating the responses for app 1, which was the title for the application with app 1. Although you can see that the weightage is 10, it's going to take a couple of minutes before these changes actually propagate. I'll wait for the changes to propagate and then head back. Now, as you can see, the application 3 is currently providing the responses for the request. It took around 20 minutes for these changes to actually propagate. Let's go ahead and in the next video try to take a look at high availability and disaster recovery comes into action. So the concept of high availability and disaster recovery comes into action when we have multiple applications deployed on the cloud or on premises in a hybrid solution. High availability can enable the traffic managers to forward the network to the healthy and active endpoints, whether they would be on premises or on the cloud. First, let's head back to the Traffic Manager profile and take a look at how we can configure the disaster recovery. As you can see, if we head back to the service and send a request over to it, you can see that application 3 is still providing the response to our services. So now what we are going to do is we're going to stop the application 3 so that all the network that has been forwarded to the application 3 has to fail. Now that our application has stopped, if we revisit the application, you can see that it is now showing error 403 and the web application is stopped. This is the message that your users are going to receive if you are using Traffic Manager to load balance the applications and to provide high availability. So now I will pause this video for a couple of minutes and let the DNS changes propagate through the Azure Traffic Manager and then toward the DNS name resolution services. Now, as you can see, if we try to reload the pages, all the traffic is now forwarded to app 1, which was the other application endpoint which was configured to receive requests if one of the endpoint has failed. If we head back to the endpoints tab, you can see the app 3 now has the monitor status set to stopped, although the priority was set to 1. The priority of 1 means that this is the top priority within the endpoint. So now we can just go ahead and start the application and refresh the endpoint state. Although you can see that it's currently saying that the service is stopped, it's going to take a couple of minutes before the Azure Traffic Manager receives a success message from the application, and then it will try to forward the request over to that endpoint once again following the priority for this profile. The downside with Traffic Manager is that since it works on the DNS level, it does not control each and every single request. It is only able to provide the IP address or the host name for the service that is going to respond to the user queries. So if your requests are cached for, let's say, 30 minutes, for the 30 minutes, the user is only going to send the request to that endpoint. And so after 30 minutes, your user is going to refresh the DNS records, and maybe then Traffic Manager can update the user with a new endpoint. And for those 30 minutes, your service is going to be down for the users for that region. One way to solve this problem is to keep time to live value as little as possible. You can use a 1 minute time to live value so that your Traffic Manager profile or the DNS is polled every minute by the users. But this increases the amount of requests that your Traffic Manager profile will receive. You can utilize other services such as Azure DNS and deploy your services on top of Azure DNS itself, so that each time your service goes down, you can automatically notify the Azure DNS and change how requests are propagated on the Azure Virtual Network itself. Although that is out of the scope of this course, but you can explore it on your own. Now, let's go ahead and take a look at how basic metrics and usage of the Traffic Manager can be reviewed in Portal. To study the application usage of the Traffic Manager profile, we can head over to the monitoring section, and under the metrics we can explore a couple of options that are provided by the Azure Monitor, using which we can check out how many times our application had been polled or the endpoint status which was, and so on. We can also go ahead and change these settings, the charting, and so on. This service is provided by the Azure Monitor and it can be performed within the portal itself. So we can study the metrics for this traffic profile, such as the number of queries or the number of responses and so on. We also have another service, the Traffic View, which basically takes the overall request for more than a week and then generates a heat map for the content. Since our Traffic Manager profile was created just recently, that is why it does not show any information on the heat map. Once your traffic profile gets older for a couple of days, you will be provided with some information over here. Then another major service by the Traffic Manager profile is the Real User Management. It provides your application with a script that you can integrate with your applications. You can go ahead and generate a key. Once done, you will be provided with a key as well as the JavaScript code that you can integrate within your applications, wherever they would be. Using this key, you can study how your applications are being utilized by the users. So these are a couple of ways in which you can study the user activities, but just note the fact that the Traffic Manager profile is only there to support the traffic control flow. It is not there as a monitoring or tracking solution. Let's summarize this section now. The Traffic Manager supports load balancing as well as disaster recovery. Although it's not the most efficient solution available, because the load balancing solutions are also available inside the app service, which are automatic in nature, and disaster recovery can be well managed in the infrastructure as a service using the Azure DNS. We also saw that there can be multiple types of endpoints that can be configured for the Traffic Manager. Multiple Traffic Managers can be nested inside the Traffic Managers to support multiple regions or resource groups. We then went ahead and took a demonstration of how we can create and manage Traffic Manager profiles. We also studied how we can create different type of profiles for different purposes. We then lastly saw how we can monitor the network traffic. Now, in the next section, we will take the monitoring, tracking, and analytics and explore how Azure solutions can be used to monitor and track the performance of our applications. Now that we have seen how we can develop, deploy, and manage our solutions on Microsoft Azure, let's go ahead and take a look at how we can monitor and track our solutions, their performance, and how our users are utilizing the services, and whether everything is okay on the production. In this section, we will focus on the monitoring of our packages that are deployed on the cloud. We will start with the introduction of Azure Monitor, which is an infrastructure as a service level solution provided by Azure. Then we will go ahead and introduce the Azure Application Insights, which is a PaaS offering for the tracking, tracing, profiling, and monitoring of the solutions. We will go ahead and take a look at how SDKs can be integrated in the platform as a service category using JavaScript or the native package managers. We will also go ahead and take a look at how we can generate the reports for all the metrics and how we can utilize the dashboards to preview all of our reports that we have created, or how we can create new reports. But first, let's explore how Microsoft Azure enables our services to be monitored using the help of Azure Monitor. First thing to understand is that Azure Monitor is basically the umbrella service that contains a plethora of the services that are available for monitoring, for tracing, for profiling, or for logging purposes. The solutions span across a couple of options such as the native services for Windows or Linux virtual machines. It also enables developers and operational teams to monitor databases, applications, or networking resources. Just the way we saw in the previous section, we were able to monitor the Traffic Manager profile using Azure Monitor within the portal. It supports native metrics and the metrics explorers. It also provides reporting tools such as the charts and tabular format reporting services. However, since we are trying to focus on the platform as a service offerings, we will not be looking into the Azure Monitor because Azure Monitor falls in the IaaS category, and we have to find a solution that is easier to maintain and does not require a lot of configurations on our side. The monitoring on the Azure Monitor happens that you only have to install the monitor or the client of the monitor inside the virtual machine. Microsoft has provided the packages for Windows or for Linux virtual machines that you can install, set up, and see real-time insights and tracing information being flooded into the Azure Monitor, on top of which you can utilize the reporting services to understand how your resources are being utilized. Azure Monitor has built-in integration for infrastructure as well as for PaaS components. And a pretty good example of this we have already explored in the previous section. An Azure Monitor can go ahead and monitor anything that is deployed on Azure and anything that can be connected to the Azure subscription. Azure Monitor also supports custom data sources using the Data Collector API, using which you can ingest your own custom metrics inside the metrics bucket so that Azure Monitor can then go ahead and generate the reports for. But we will have to limit our reach to Azure Application Insights. The reasons are that Azure Application Insights is a platform as a service offering. It has native SDKs, which means that we can go ahead and develop the solutions on top of while still utilizing the scalability and high availability of the platform components, since Azure Application Insights is cloud-hosted solution and is highly available. So let's go ahead and take an overview of Application Insights and see how it basically functions. Let's go ahead and take a basic introduction of what Azure Application Insights is as a service and how we can utilize it. A basic monitoring, tracking, and analytics service provided by Azure Monitor for the platform as a service category. It is very easy to integrate and to extend. In most cases, all that you need to do is just download a JavaScript file and rest will be managed by Application Insights itself. It supports native dashboards within the portal, and it also provides you with some reporting tools that you can utilize to generate your own custom reports on top of the metrics that have been collected by Azure Application Insights. And it supports easy integration with other tools and services such as Microsoft Excel or Power BI. Although Application Insights is a PaaS offering, it can control the entire HTTP traffic monitoring as well as logging middleware. It can also track the dependency sources as well as the overhead that they are having on your individual services. Since we remember that we have to deploy our solutions in cloud-native fashion such as the microservices, Application Insights can help us understand which of the services is taking longer to load and respond, and we can go ahead and fix those problems in those services only. Not just the HTTP traffic or the dependencies, Application Insights also controls and stores whenever there are problems in the code. It also enables you to monitor and store custom events. Apart from all these services, it also stores information about user sessions, active sessions, monthly visits, new users, returning users, location of the users, and much more information about the host as well, such as the virtual machines in which your application is running, the container information, or information regarding the app service where you have hosted your application. Now, let's go ahead and take a quick demonstration of the Application Insights. Back in the portal, create a new resource, search for Insights, and you can find Application Insights in the query results that Azure returns you with. Go ahead, select the service, and click on the Create button. Once you click on the Create button, you will be provided with a very basic form that you can use to fill in the details for the application that you want to monitor. Application Insight provides different information and metrics tracing services depending upon the application or the type of application that you are using. Once you provide the name, you can go ahead and select the application type. There will be a bunch of options for this: ASP.NET, Node.js, Java, General, or App Center application. Select the subscription, resource group, and so on and so forth. Once the application has been deployed, you will be provided with the dashboard for this service. a couple of options such as the application map, servers, the usage information such as the number of users, events, and much more. All this information is provided so that you can control and explore how your application is being used, what performance it has, and if there are any failures or production bugs that you need to care about. You can also go ahead and consume the analytics service and explore the metrics that are provided by Azure for your services. If you have explored the Azure services, you will see that this is basically the logs analytics service by Microsoft Azure, which allows you to create charts and reporting dashboards for your services. On the left side, you have the metrics that have been collected for you, such as the traces, custom events, page views, requests. And on the right side, you have the query editor that you can use to write your own queries. Select the time range that you want this query to execute for, and then just go ahead and run the query. The logs monitor will go ahead and fetch all the logs that are available for you, and it will return the overall logs for you. Since our application insights is a new resource, there won't be any logs available for you to review. Let's just go ahead and integrate the application insight service with our app service and enable the flow of metrics from app service over to the application insights and see how we can generate the reports for our metrics. The application insight basically provides the SDK that you can utilize to integrate with your own services, or you can use the in-portal configuration that allows you to connect with your own services such as the app service and enable the flow of data for the metrics from one service to the app insights. The application insights SDK or the native SDK enables richer data connections such as the custom events and metric logging, and it also enables you to control and write the message format that will be passed over to the Azure application insights. Microsoft provides official SDKs for most of the runtimes and platforms that are provided and used on the clouds, and the application insights SDK is a really very lightweight and background thread enabled library which does not have a dramatic overhead on top of your own applications. So let's go ahead and connect the application insights with the app service. Head over to the app service which was deployed for this section, and then just scroll down all the way until you find application insights under the settings. As you can see that application insights is basically an extension to the app service. Go ahead, turn on the site extension. Site extension basically will enable you to connect your existing application insights instance with this application. Once done, select an existing resource because we have just created a new resource, or you can go ahead and create a new resource. You can also find the native SDK support within this page. You can find out how you can install the native SDK for the most important runtimes such as .NET, .NET Core, or Node.js as we have been utilizing throughout this course. You will find the instructions to do so over here as well. We will just go ahead and utilize the in-portal integration of both these services and click apply. Once you will click apply, it will install the extension and configure your app service to transfer all the metrics over to application insights. We will wait for a couple of minutes so that the application insights extension has been installed, and once done, now let's go ahead and browse the website. We will be sending a couple of requests to this website so that we have a couple of requests to test our application on top of. After a couple of minutes wait and a couple of requests, I'm heading back to the application insights overview, and as you can see, I can find a couple of metrics being plotted on the charts over here, such as the number of requests. Let's head over to the analytics tab and try to send a query to the application insights and see how it behaves. Write requests, which will basically provide you with information about the requests that have been logged. As you can see, it provides some information about the requests that have been received by our application. We can also go ahead and draw out the graphical representation of our services, such as in the form of a pie chart. We can also configure how the data is being presented, the legends, the axes, and so on. So that is how you can go ahead and generate your own custom charts based on the data that is provided and the performance of our application, also the metrics for the users that are utilizing our services. Now let's go ahead, and in the next video, although Log Analytics provides us with the dashboards and reporting capabilities, we can also create a full-blown dashboard on the Azure portal, which provides us with a complete overview of the analytics and the performance of our application, also the metrics for the users that are utilizing our services. Although Log Analytics provides us with the dashboards and reporting capabilities, we can also create a full-blown dashboard on the Azure portal, which provides us with a complete overview of the analytics and the performance of our application, also the metrics for the users that are utilizing our services. The dashboard basically is an in-portal reporting solution by Microsoft. The reports and metrics are richer because everything from the app service to users to our application's code all the way to the dependencies is provided in a single dashboard. The alerting for most problematic scenarios is already enabled and set up by default, and we can also go ahead and customize or create our own alerts on top of them. We can also go ahead and download the telemetry information or integrate it with other tools. To do so, let's head back to the Application Insights service and click on the Application Dashboard. This will generate a complete dashboard for us inside the Azure portal and take us back to that dashboard. As you can see, it just created a new dashboard for us. It called it App Metrics AI Dashboard and has created a complete dashboard which will provide us with a 360 view of our application, including the number of sessions, server response time, availability, and so on. There is nothing visible because we don't have much information to generate the report, but once the data starts to flow, you will see a complete overview of the application usage as well as the users who are using your application right over here. So these were the two options in which you can generate the reports right inside the portal using everything that Azure has provided you with. Now let's go ahead and in the next video try to see how we can utilize other services such as Power BI to generate our own reports. Let's go ahead and power up our Power BI applications and generate the reports for our application metrics and see how custom dashboards can be created using Power BI. You can also go ahead and utilize other services such as Excel or your own tools or libraries that you have. Power BI is a business intelligence product. It supports rich dashboard creation. It has built-in support for data sources for quick integration. So for example, your Application Insights or other Microsoft products have out-of-the-box support for connectivity. It also features a model editor, a relation manager for data, and best-in-class reporting software. The requirements to follow along with this part of the course is that you must have installed the Power BI desktop, which we did in the first section. You also must have Application Insights data connection, or you must download a CSV formatted data that you can use to generate your own charts. And you must also have enough compute power to support the dashboard creation. You can go ahead and review the requirements for the Power BI software package on powerbi.com. Let's head back to Power BI, and as you can see, I'm currently on the dashboard and I have used a couple of controls to generate this report. I have a couple of pages which also have some different reports which are generated using the data that was provided by Application Insights. And now this is the data view for the overall data, and as you can see, this is basically the data that is coming directly from the Application Insights. Now we also have model editor for the relationship between the data types. We do not need to use that at all. Let's head back to the dashboard, and as you can see, we have a couple of more controls, such as on the slow responses page, we have pages which have the slow responses. There is a list of the pages as well as the HTTP requests that they receive, along with the time that it takes for this page to respond to the request. On the right side of it, I have a control that shows the geographical information for each of these requests. And as you can see, that basically this generates a map of countries that are receiving the requests and are providing a response time. We can go ahead and select an individual request, and this will also alter the state inside the control on the right side and will provide us with the countries only that are receiving the request home index with a head and are also providing the response time that is provided in the legend. If we go ahead and modify the selection in the left side, it will also make the modification in the selection on the right side. And this is the power of Power BI that allows you to quickly explore the metrics of your application and study how your application is performing in different regions of the world. You can also go ahead and edit the control variables such as the title that is used, the field information, the color, and so on and so forth. And these are all on you as well as your enterprise's needs, as you might want to support the customers with regular day business operations and so on. Now, let's just go ahead and explore another interesting feature of Power BI before we wrap up this section as well. Let's take a look at a very interesting feature of Power BI when it comes to the exploration of metrics. Power BI basically supports the machine learning based capabilities that enables you to ask quick questions from the data sets, such as you can write performance bucket and it will go ahead and filter out the resources for the performance buckets, and then you can go ahead and ask different questions such as what is the performance bucket inside Pakistan, and it will tell you about it for the data which is inside Pakistan. And as you can see, it has organized the data as well. So for example, we can also go ahead and ask some different questions such as count requests, and that will count the overall number of requests inside the data set. And we can also go ahead and filter the count based on the countries, such as count requests in United States, count the requests in Switzerland, and we can also go ahead and ask different type of questions based on the data as well as the most frequently used statistical or mathematical operations such as the maximum, request, and so on and so forth. So these are a couple of options that you can go ahead and explore using Power BI desktop, and by using your own data set, you can generate reports for your own applications and create dashboards. You can refresh these dashboards every day, every week, and so on and so forth. So this is the flexibility that Power BI provides you with. Of course, you can go ahead and utilize these services in Excel or in your own solutions that you might have been using. Power BI is definitely not a must. So this basically brings us to the end of this section as well. In this section, we went ahead and took a look at the monitoring as well as tracking of our packages on the cloud. We took an overview of application insights for the cloud monitoring for the platform as a service offerings on the cloud. We also went ahead and integrated application insights with other services such as app service for data ingestion. We then went ahead and generated the reports inside the Azure portal as well as inside the Power BI. And this also brings us to the end of this course.